Okay, everybody, we're going to get started. So you could all find your place in a chair. So thank you all for coming today for the Soy Innovation Center SpringBoard Challenge, which is the first of what we think are going to be a number of exciting events over the years as we build out an ag tech economy in the state. My name is Todd Main. I'm director of the Innovation Center, and I take this time to introduce John Lump, our CEO, to make some welcoming remarks.
Thank you, Todd. Good afternoon, everybody. Hey, all right. I like that. I don't want to mess up the computer. Welcome to the SpringBoard Conference. Welcome to the SpringBoard Conference. My name is John Lump. As Todd mentioned, I'm the CEO of the Illinois Soybean Association. On behalf of the 24 volunteer former board members, who none are here today because they're planting their crop, so that's a good thing, and the 45 staff that we have, I'm thrilled to welcome you to the 2 days dedicated to sparking collaboration, fast-tracking commercialization, and unlocking new market opportunities for soy-based products. Work that lies at the center of ISA's mission and the vision behind our Soy Innovation Center. SpringBoard isn't just another conference, it's a platform for new ideas, strategic partnerships, and forward thinking that helps bridge that gap between innovation and impact. Whether you're a researcher, scientist, manufacturer, investor, or farmer, your presence matters. This is where meaningful connections are made and where ideas become products and move our markets. As I look around the room, I see more than just industry leaders. I see a group of innovators, pioneers, and problem solvers shaping the future of our bio-based products. And in the future, I see something even greater for American farmers: profitability, resilience, and long-term success. The investment ISA is making together in the commercialization of soy-based products is one of our most meaningful ways we can secure a strong future for our farmers, our communities, and our supply chains. Through ISA's leadership and momentum of the Soy Innovation Center, we've already made great progress, and we're just getting started. Thank you again for being here and for lending your expertise, creativity, and partnership to this important effort. It is now my pleasure to turn it over to Jeanette Tamayo, the Interim Executive Director of the Illinois Innovation Network. There you go.
Thank you. John, correct. I am not Jeanette. She's not able to be here right now, so I'm going to step in. I'm Doug Cruitt. I am going to speak on behalf of both Distillery Labs. I'm the executive director here. I also serve on the Illinois Innovation Network alongside Jeanette. So we are going to switch. You know, all of these things occur in this building every day, and one building that is connected through the Innovation Hub throughout the state of Illinois. So 14 other hubs. So a lot of you reside on other academic campuses. You're researching a lot of cool things. We got some new friends from NIU that got some really cool stuff, so definitely check that out. But it's these types of collaborations, conversations, where we get a diverse group of people in a room at the same time, throw a topic out in front of them, throw a challenge, throw a problem, and that's what, it's what we do here. It's what we do here in the Midwest. It's what we do in Central Illinois and throughout the entire state. Good challenges ahead, But just excited that we get to have this conversation here today, knowing that whenever you all leave this building, those ripples will go on throughout, and new innovations will, new collaborations will come out as well. So real quick housekeeping stuff. Restrooms are right there. Your exit's right there. If anybody needs to step out and take a call, that door is open. It's just an empty classroom right now. More than welcome to go into that room. Also, back have plenty of pop in for a quick phone call. Beyond that, enjoy your time. Thank you for coming today. If you've not already received your validation, Tech Plaza is across the street right there. If you parked there, we can validate it. My apologies if you did not park in One Tech Plaza, we cannot validate it. Thank you again for being here, and enjoy your time. I think if you hold it down a little bit further.
Okay, we're going to see if we can learn how to use the microphones. So what I thought I would do to get us started is just to give you a little context about the Soy Innovation Center, which is a new initiative that was started by the Illinois Soybean Association about almost a year ago to support the research and commercialization of new uses of soy. And there's been a long history of research funded by farmers to innovate with soy. One of the first big ones that you all know about that's ubiquitous now is biodiesel. And that came out after a long series of research projects and development over a decade. And now there are a number of other things that are out there. One of the ones that you'll hear about later today was developed by our colleagues at Distillery Labs. They have developed some stuff that you can now buy in Home Depots and Menards and Lowe's all across the country. And that's an exciting thing. The innovation that we're talking about today at the Innovation Center is really a couple of different things. The first one of the innovation is that the farmers are going to take an equity position in some of the efforts. And for a long time, farmers have given grants to organizations to do research and have not taken an equity position. But we want to innovate and do a little bit better on that. And the reason is that we want to grow our ability to fund research. And so we're going to share in the back end on all of these investments, but we want to also then take that money and put it back into more research and sort of create a long-term sustainable initiative. The second innovative thing that we're doing at the Innovation Center is that we're funding the research, but after the research is done and the patents are applied for, there's been a long history where projects go into what is known in the industry as a valley of death because they never go anywhere. They sit on a shelf. And nobody has cracked the commercialization piece of this puzzle in a systematic way. And that's one of the things that we're going to do at the Innovation Center, is that we want to provide the support to get those businesses up and going so that they can then start to contribute to the larger economy. The third innovation is that we're going to focus on the demand side of the equation. How do we stimulate the demand? How do we find products that will utilize the soy once it's been harvested? If you look around today in the venture capital world, you'll find that there are dozens, if not hundreds, of organizations and entities and research facilities and companies that are focused on how to grow a better soybean or how to work on the production side. Well, our innovation is that we're going to work on the other end. We're going to work on it once the bean is already grown. And how do we develop markets? And this is really a natural extension of what we've been doing for the last 60 years at ISA. Primarily is that we've been developing international markets, although certainly some domestic markets as well for soy. But we also want to develop markets that will use soy in new and innovative ways. And then the last thing, and this is sort of the driver for us, and that is that our directive from our farmer leaders is our job is to move the pile. You know, Illinois grows more soybeans than any state in the country. And I think we've got a big pile of soybeans to move. And so finding new markets and new ways to do that is an important mission for us. So let me talk a little bit about our first project that we did. And this was the development of a lubricant that is used on heavy machinery, sort of a tube grease, if you will. The equivalent on the market, which is a petroleum-based product, is called red and tacky, which you may be familiar with. So we wanted to develop a soy-based alternative to that would work in a bio-preferred setting and be available in a price and performance competitive way to what's leading on the marketplace. And so we teamed up with our friends at Arable, and they have done the research now to develop that product. And it's the first one coming out of the Innovation Center. We have sent it out to labs for third-party testing, and it's passed all of the tests at the lab. And we have filed a provisional patent, and now we're in the process of licensing discussions with a number of different companies to take that public and make that a product that's available. Our next step is that we're going to do field trials, and we're in the process of scaling up a batch that we can then have our farmers test out in the fields. And so my point to tell you this is that soy is an amazing product which you can use for almost anything that has a petroleum feedstock. You can use the oil, you can use the meal, you can use the various component parts. And so that's kind of what brings us here today is to expand that. So let me talk a little bit about the SpringBoard Challenge, and we'll get into this in greater detail tomorrow. But the goal here is, after understanding what it takes to get one product, we thought, well, you know, to really make this go, we're going to need to have multiple products out there in the marketplace. And so we did a bunch of research and worked with some of our coalition partners and identified 5 research areas that we think have promise that would worth a larger investment in time and energy. The first one of those is to continue building on the work we did with biolubricants. And the next stage of that is to develop a food-grade lubricant that can be used on food manufacturing machines, which we have a great number of in Chicago. And so we wanted to develop a food-grade lubricant. The second one that we want to develop is a bioplastic, a soy-based plastic. And traditionally, this has been something where they would substitute soybean oil for petroleum, but we actually want to do it with soybean meal and extract the protein from that and use that as a feedstock. And so we're in the process of doing a research project on that. The third one is something that you've probably heard quite a bit about, which is the race to find a non-toxic alternative to PFAS. And these are forever chemicals that are out there. It's really a family of about 18,000 chemicals that are used very widely across the country. And we're intrigued by the work that is being done at the USDA labs here in Peoria. And they're actually taking a leadership position in some of the science behind that, and then we wanted to expand that as well. And so that's a third area that we're focused on. The fourth area is biotextiles. And you think about this as sort of different, but you think about nylons and rayons and synthetic materials that traditionally have a petroleum base. Well, you know, we think that they could have a soy base, and so we've been doing quite a bit of thinking and research on that potential. And then the final one is polymers, which are sort of the building blocks of a lot of chemistry and industrial processes. And so we're going to look at using soy for those as well. So the goal is to challenge the universities here in Illinois and elsewhere if they're interested to look at these projects, and we've developed some challenge statements which identify the problem, and then come up with a research plan which we will fund to bring to the marketplace. And so that's the reason that we're here today. We wanted to kick this off. We're going to give folks some support to write a full-blown research proposal, and then in September, they will get, they're going to be reviewed by a panel of scientists, and then also by a panel of farmer leaders. And if they win the competition, then we'll fund those, and that research will start in the fall, and then be completed over the course of the school year. We actually have a couple of other research efforts I just want to touch on. There are some folks here today that may, if you get a chance to talk to them, one of the things about PFAS is that it's an important ingredient in the foam fire retardant that's being used by firefighters all around the country, and it's coming out that it's actually a real health problem for them. And so we're going to have do some work in developing a alternative to PFAS in those firefighting foams, and that's a very exciting opportunity. I've touched on the bioplastics, but using soy protein as a component of that, and we've got some research projects going there, and then also using soy hulls as a feedstock for the fermentation process, for industrial fermentation. And so let me bring to a close just sort of the parameters that we're going to operate in with the SpringBoard Challenge. And our goals really is we want to, as I said, develop a sustainable pipeline where we have projects that come out. And there are a few folks who are in the venture capital world that are here in the audience today. And our goal, and my promise to you, is that we are going to be the go-to place for investable projects. Because we're going to do the research, and then we're going to support the commercialization so that when we get through the process and have an investable project that we present, it's going to be of the highest quality. And that's what our goal is. The second is that we want to be an engine of commercialization. And we want to have multiple products coming out every year and a pipeline so that we start to capture what is, I think, the most vibrant area of the state right now, which is in Peoria. I mean, the work that's being done here, utilizing the science that's being done here, is really, I would say, it's the secret that Champaign doesn't know about yet. And so we want to be part of that, and we want to be supportive of that. And then the last thing, and this is sort of a larger scale, but it's important to recognize, and that is that Illinois is uniquely positioned to be the global center of the ag tech economy. And what I mean by that is that we have all the pieces of the puzzle. We have world-class research facilities, we have world-class universities, and we have world-class financial players and mechanism and markets to put all of these things together. And it goes without saying, we have the best farmers in the world. And so that's the challenge that we have in front of us. And in a time when people may get frustrated or unsure about the volatility of the world, one of the things that we can always remember is that Illinois was built on farmers' labor. That's what built this state. And it is the #1 sector of the economy. And farmers, as we know today, because they're out in the fields right now, understand that sometimes it takes hard work and sometimes you just got to do the work yourself. And that's the promise that's in front of us, is that we can build an ag tech economy here in Illinois to supplement everything else that's going on, because we've got the people and we've got the talent and we've got all the pieces of the puzzle. And so that's the opportunity that is before us today. And so thank you all for your time, and we'll continue our next couple days. So thank you.
So our next two speakers, we have Barry and we have Brett. Brett, did you bring a PowerPoint or did you send it? Okay. Sure, that's fine. We're just, give us a second. So we're going to begin with Brett Chisholm, who's the research leader in plant polymer research at the USDA National Center for Agricultural Utilization Research here in Peoria. And then following Brett is Barry McGraw, founder and CLO of Arable Research Labs. Todd mentioned Arable in his presentation. So we'll begin with Brett and then move to Barry, and then Barry, we have you loaded up, so we'll just boot you in when you're ready.
Yeah. Sorry, I should have pre-booted my computer. It kind of came up sudden. Okay, thank you very much. That was actually faster than I expected. It's working better here than at work. Peter, thanks for the introduction. As you mentioned, research leader for the Plant Polymers Research Unit, located here in Peoria. So what I'm going to try to do, I have kind of a general overview of different components that come from agricultural crops, purified polymers, and then different exemplary applications where they're currently used, and hopefully that will provide some thoughts on other potential applications. So, just one, that's not advancing. Okay, there we go. So a quick description of the National Center for Agricultural Utilization and Research. So this is part of USDA's Agricultural Research Service. So we have hubs that exist in different parts of the country, and NCAR is basically serving the Midwest area. So we focus a lot of our research on corn, soybeans, other crops that are grown in the Midwest, a lot of specialty crops, cover crops. And it's been in existence since 1940s. And right now we have about 175 people, most of them scientists. And we bring in about 300 million to the local area in science and technology. In addition to doing research to help valorize crops for farmers, we also contribute to various local activities such as STEM outreach programs, workforce development, local and regional businesses. We provide support, research support, and then also events like this to help basically serve the farming community and the agricultural economy. So in terms of successes, the lab here in Peoria, which I think is probably less than 10 minutes from here, has had some very major impact on the country and even globally. So for example, if you live in Peoria, you're probably aware of this, but if not, you may not know this, but penicillin, the process to mass produce food, was actually developed here in Peoria at NCAR. Also, dextrin, which is a commodity polysaccharide, was discovered here at NCAR. Xanthane gum was also discovered here, and those are commodity materials that are used in all kinds of food and pharmaceutical applications. Various low-fat ingredients, bio-based coatings for cosmetics, oil drilling, and then also the early versions of superabsorbents for diapers was developed here in Peoria. And overall, we had quite a large impact, a lot of businesses founded based on these discoveries and new commodity materials. So basically what I want to do is kind of at a high level break apart agricultural crops and then show you basically what polymers, what materials can be extracted from those components, and then go through and provide some examples of where they've been used in non-food industrial applications. So from the whole plant point of view, we can separate that into basically two basic components. So one is the seed. So for soybeans, it's the bean. For corn, it's the kernel. And then you have everything else that's left over, which is typically referred to as the stover. And so both of these general components provide different polymers, different materials that can be extracted and purified and used for various applications. So from the seed, you get the oil, so the vegetable oil. You also get a starch component as well as protein. So the seed has probably, well, it does have the highest value of the crop, but we also have the stover, which doesn't really get much attention, but is also a feedstock for generating cellulose as well as lignin, and there are more and more applications looking at utilizing these components for non-food applications. So I'm going to spend a fair amount of time on the seed oil, kind of the stover part, and focusing on some of the work that we've been doing in that area at NCAR here in Peoria. So with regard to the vegetable oil, so vegetable oil is relatively easy to extract. It's relatively low cost. Depending on the crop, can be very abundant. One of the nice things from a chemical point of view, if you're a chemist, is that it has a lot of functional groups that you can use to do different modifications and tailor it for different types of applications. And every vegetable oil has a different composition, and so it can be used for different applications. So depending on the application, soybean oil might be good, linseed oil might not be good, and vice versa. So some of the applications right now that soybean or that vegetable oils are used directly without modification are shown here. So for example, wood finish, so linseed oil is typically used as a wood finish to provide some hydrophobicity and to protect the wood. Artist paints are generally based on linseed oil. Basically, linseed oil is used primarily because when exposed to oxygen, it will actually form a cross-linked polymer that provides prevents water penetration. And although historically linseed oil has been used, hemp oil is probably as good or perhaps even better, but it has not been utilized because of restrictions on being able to isolate hemp oil in the United States and use it for applications. Also, creams and cosmetics, typically those are more like palm oil, coconut oil, because they're solids and they're more oxidatively stable. Another one that's come up maybe in the last decade, 15 years, is using soybean oil directly as a lubricant or a processing aid for tires. So tire treads are difficult to process, but because of the structure of the vegetable oil, it will dissolve the polymers and basically make the processing of the high molecular weight rubber much easier. So a lot of the tires that you buy now utilize large amounts of soybean oil as a processing aid and to tune the properties of the rubber. Also, inks, vegetable oils are also used in inks like in wood and artist paints. So that's using the vegetable oil directly, but there's lots of sort of industrial scale chemistry that can be used to take the soybean oil as a feedstock, modify it into a different material that has features that enable new applications. So all of these processes are practiced commercially right now. And so, for example, you're probably familiar with biodiesel. That's doing a process of methanolysis. And basically, that's used as a fuel, can also be used as a cleaner because it dissolves greases and oils. Hydrogenation, which was used for cooking, Crisco in the past, can also be used to generate waxes, used as an internal lubricant for vinyl siding to make the profiles nice and smooth. Polyvinyl chloride, which is a common plastic, so it's used in vinyl siding, but also all kinds of other applications. An epoxidized version is used basically as a stabilizer, and this is used in very high volumes. And basically, when the polyvinyl chloride is processed, it can start to degrade and generate hydrochloric acid, and the epoxidized soybean oil basically scavenges that acid so it's not released as a gas and prevents corrosion of metal. A lot of the oil-based paints that are used for industrial applications are based on vegetable oils, linseed oil, and that's through a transesterification process. So a lot of the spray paints that you buy are based on what they call alkyd resins, and that's through a simple transesterification process of the soybean oil with other chemicals. Vulcanization is another process that's used. For example, pencil erasers used a cross-linked vegetable oil called Factus, and it gives the kind of crumbly aspect of pencil erasers. It can also be used in other rubber components as a processing aid. Some other two-step processes that are used commercially, epoxidation followed by acrylation. That's used for example, inks and coatings that can be cured by radiation. So UV light converts it from a liquid coating to a solid coating in seconds. And then also polyurethanes. The polyurethane industry uses soy polyols for foams, coatings, elastomers. So that's a huge market. So even right now, these chemical processes are being used, and you can take advantage of the chemical features of just the oil itself to generate a wide range of new non-food industrial applications. So one development that came out of NCAR and the bio-oils group, so they developed a material called estaloids from vegetable oil, soybean oil, and that has been certified, American Petroleum Institute, to be used as actually a motor oil, and that's derived from soybean oil. So moving on to, starch. So starch is used a lot in food, but it also has a lot of value for non-food applications. And the starch itself, depending on what crop it comes from and also what variety of crop, you can get different properties of that starch that enables different applications. And in addition, there's lots of chemical processes that can be used to modify the starch to further change the properties, such as hydrolysis, oxidation, esterification, and all of these materials are commercially available from different suppliers like Primient, Cargill. And so some of the main applications that starch is used in the industrial area, as well as modified starch, are in paper making, so that's by far the largest volume. Also modifying fibers for textiles, a lot of biodegradable packaging, so biodegradable clamshells. Also, I have some samples over here of starch-based packing peanuts, so replacing the polystyrene non-biodegradable packaging peanuts that are used to protect goods that are shipped. You can also create films that are biodegradable for food packaging applications. Also, using starch, you can modify the starch, utilize plasticizers, also blends with other biodegradable polymers to form biodegradable plastics. Also in things like plasters, gypsum, it's used in building materials for construction applications. Adhesives, so for example, a lot of the cardboard boxes that are glued together, those are starch-based biodegradable adhesives. Of course, bioethanol, using starch as the feedstock to generate glucose, and then finally ethanol is a primary feedstock for bioethanol. And then also pharmaceuticals, so using as a binder for capsules and also for tablets as well. So an example of some technology that we're working on at NCAR that's been going on for a while. These are called amylose inclusion complexes. And basically what they are is it's combining starch with vegetable oil components, so fatty acids and modified fatty acids. And basically when combining these, you can physically entrap the fatty acid within the starch, and it forms nanoparticles that can be used as emulsifiers. So you can see in this picture to the left, this is a starch vegetable oil complex that's being used at about 1 weight %, and it is emulsifying oil and water mixtures. It also provides for a barrier for water penetration, so for wood coating, paper coating. So this is very thin. This is not like a paint layer. This is atomic level absorption of these particles onto the surface that provides hydrophobicity to both paper and wood. And as well, based on the fatty acid type, we can modify that to impart antimicrobial, antifungal properties, and also pesticidal properties. So these are largely bio-based, so either 100% or 90% and higher bio-based material. And you can see here, this is a potato where the top has been untreated, and we introduced a fungus that is responsible for potato rot. And you can see without the treatment with the amylose inclusion complexes, the disease spreads, but where we treated the potato and then inoculated with the fungus, it basically kills the fungus and prevents it from spreading and destroying the potato. So this has been patented. It also is affected towards nematodes, so we have multiple patents, and now we're looking at putting it into more formulated products to try to get the technology licensed and into the market. Protein, so this is specific to soy, but as I mentioned, it's easy to remove the oil from the soybean, and then you can go through multiple processes to basically get different purities of protein from the defatted flake that's obtained after oil extraction. So we have soy flour, soy concentrate, soy isolate, and of course, the lower the protein, the less expensive it is. And one of the unique things about proteins is that these are very complex molecules. Of course, they can be modified, but they tend to be in kind of a globular or particle type shape compared to some of the petroleum-based polymers that we're used to. But nonetheless, based on processing the type of protein and other additives and modification, they have been successfully converted into biodegradable films, even for edible type applications. Certain proteins can be spun into fibers. There's an example of some electrospun corn fiber, Zane fiber. They also tend to be surfactant-like, so certain varieties serve as emulsifiers to emulsify oils and waters for cosmetic-type applications. Pharmaceuticals can provide some barrier properties and controlled release of the drug by basically providing a barrier, a semi-permeable barrier that can be digested over time. Also, wood adhesives, and I'll go into one more slide on that since we had a significant development within NCAR on wood adhesives. And then also some interesting results on using protein basically as a filler for rubber compounds to strengthen rubber compounds. So as an example, here's some work that was done by Dr. Mila Hojila Evangelista, who's here in the audience. So Georgia Pacific, during the time that there was mad cow disease, they were using basically cow blood as an extender for their wood adhesives. And so they wanted to get away from that, and she developed technology to use soy flour as a substitute. And basically they were looking for something that was a drop-in replacement, so no other changes in formulation. And that was quite successful, so here's some actual images from a manufacturing trial. And they used that formula for foamed plywood adhesives in 2 different mills for 3 years during that period. And I have a sample here on the table that shows those plywoods. But that application in itself over that period, that was a 250,000 bushels of soybeans per year for this particular application. So that was quite a successful product. Sang-Hoon Kim, who was in the group, he does a lot of work with encapsulation, so using protein to encapsulate high-value materials. He also developed a technology for basically anti-fog hydrophilic coatings that are protein-based. So the technology involves taking protein and dispersing it in water into micron-sized particles, and then he modified the surface with basically the same compound that's used in superglue, so cyanoacrylates. And then when that's put down on a substrate, those grafts that are on the protein enable adhesion to the substrate, and then the protein denatures and the hydrophilic surface is created that sheds water. So you can create surfaces that are anti-fog, so untreated and treated. And here's a quick video, hopefully this will work, where he's actually taken his own vehicle and he's using car wash here. So he's basically just washing without treatment first, just to wet the surface. And then on the front windshield, he'll apply this modified protein dispersion onto the car, wash it off, and then you can kind of see what the effect is. So he's applying it. Now he's using the power washer, which you would think would wash it off, but in fact, as you'll see in a minute, it adheres strongly to the surface and provides water, hydrophilic surface to let that water rinse off without creating droplets. So you can see in the front there, it's completely wetting, and then in the back where it's untreated, it's beating up and causing difficulties looking through the glass. So this is quite adherent, and it's bio-based, and this has been patented, and also something that looking to move forward. Another one, and this is something that was done prior to me joining the group about 1.5 years ago, and the scientist has since retired, but I think that it deserves some additional work. And it's basically taking rubber, which is in the latex phase, so it's dispersed in water. So the natural rubber that you get actually comes from the rubber trees, and it's isolated from the tree as a dispersion of the rubber particles in water. So he simply took defatted soy flakes and blended that, mixed it with rubber latex, then coagulated it and made rubber material. And so using a test like is shown here in the middle, where we're basically rubber and measuring the amount of force it takes to stretch it, and then determining how far it stretches before it breaks, these soy protein particles that are embedded inside the rubber are actually providing pretty significant reinforcement of the rubber. So this bottom curve, 0%, that's without the soy protein. But you can see just adding 10 weight percent, the stress goes up, but you maintain the elongation. And as you put more and more soy protein in there, it gets stronger and stronger. So it's basically serving the same effect of carbon black in your, for example, your tires that you're using, but it's soy protein. And it's due to the fact that it has this globular shape, and there's a lot of resistance to the deformation. So at the point that he retired, this was sort of in the model compound type stage, but something that I think is very interesting. The other thing that I want to point out, and this is for you, Badri, in particular, is that as you load this up, the behavior of the material goes from being rubber-like to more plastic-like. And one of the nice things is having these particles embedded, the soy protein embedded in the rubber, is that it kind of prevents water from egressing into the material, because that's one of the drawbacks of soy protein, is it's very hydrophilic. It absorbs a lot of water. So that's something that I think is interesting for further work. We also just want to end up talking a little bit about this, the stover. So we've been looking at using stover as a source for biochar, and typically biochar is used for soil amendments, but we've been looking at it as a replacement for carbon black and rubber compounds. So when you create biochar, you're basically heating it to very high temperature, and you're getting rid of all the oxygen. So it's high carbon, very similar to carbon black that's generated from petrochemicals, from oil. And then also you can do chemical treatment of the stover. So a lot of people have been doing this from wood, but we've been looking at it from the point of view as using soy and corn stover as a feedstock to generate nanocellulose. So nanocellulose, cellulose is very anisotric, so it's very strong in one direction, very lightweight, very high strength to weight ratio. And so we were looking at using soy stover as well as corn stover for making nanocellulose. And here are some results. So Steve Peterson in the group has been focusing on biochar, but basically he's proven that you can replace 50% of the carbon black in a conventional rubber compound with biochar and maintain the same strength and toughness of the rubber. And then from the nanocellulose point of view, one of the things we found, we looked at corn stover. And what's very interesting is we go through a process of chemical treatment where we remove the other components from the stover to create relatively high purity cellulose, and then a mechanical process to basically pull the fibers apart to get these nanofibers. And when it's in this nano state, you can see that even though this is cellulose, this is a film, and I've got the film on the table over there, you can see through it, and that's due to the fact that we have these very narrow fibers, and this is porous, but still very high strength. And so this plot, this is corn stover, where we've gone through this mechanical process a number of times. And before the mechanical process, where you go from this anisotropic state to creating the nanofibers, is very weak. It's basically like tissue paper. But you can see the strength goes up dramatically as a function of the number of passes to where it's extremely strong, tensile strength and modulus after 30 passes. Now, more recently, this has been published, but more recently we started looking at soy stover, and we also modified the chemical treatment process. And this hasn't been published yet, but what's interesting is that a lot less mechanical energy is needed to get to very high strength, very high modulus. So just within 5 passes, which was the minimum that we used, we were able to create nanofibers, and then going beyond that, there really wasn't much of a change. So it's interesting, this particular chemical treatment and this mechanical process is generating nanocellulose with much less energy input than what we had previously been doing with corn stover. So that was kind of long drawn out. I apologize, Barry. It took a little bit too much time, but thank you so much for listening, and maybe there's time for a question or so. Okay, at the end. Very good.
Take your time. Take your time. Let me have the HDMI. Got it. Thank you. Sure.
Right. So I give a little bit, I don't always do this or don't always have time, but I feel like we have a little more time. So a little background about myself. Actually degree in plastic engineering, which kind of the dark side, right? The petroleum-based plastic engineering, injection molding, mold design, material selection, science. And then went to work at Battelle Memorial Institute in Columbus, Ohio. Worked in their advanced materials group for about 15 years, a lot of Department of Energy, Department of Defense type projects. I'm sorry, you can't hear, oh, not close. All right, let's try that again. Barry McGraw. So plastic engineering background, worked at Battelle for 15 years in our advanced materials group. A lot of Department of Defense, Department of Energy type projects, solving problems. That's really what I like to do. That's what wakes me up in the morning. That's why I like working for farmers. From changing the color of golf balls as they go in the water, so you can determine whether your Surlyn golf ball has picked up water and it's going to hinder your performance or not. That's the kind of projects I worked on. Silver zinc batteries for one-time use. For submarines or for missiles, working on membrane type materials for those type of batteries, so all over the place, fuel cells, and then started working for the Ohio Soybean Council. Started doing projects in the bio-based area, and that's what I really got interested in because it's a huge challenge, right? I mean, petroleum is a reason why still roughly 96, 98% of all materials are petroleum because it works great, right? You can process it easily. You don't have, these guys probably know, you don't have the smells that maybe you would have with a soy-based polymer or corn-based polymer. Everyone's used to it. But I really gravitated to kind of soy or bio-based products because of some of the challenges. Because there's no reason that we can't be utilizing bio-based materials in a lot of applications. It won't displace everything, but there's no reason we have to be using petroleum in every application when soy or bio-based can solve the problem or provide a solution. Worked for the Ohio Soybean Council for the last 12 years. A little bit the same as what I was doing at Battelle, but more of kind of managing projects or funding others. And then roughly 5 years ago decided, hey, it's not moving fast enough, and we need to do this for ourselves. So that's what came to be. Sorry, I get barely far away from that and it turns off. Arable Research Lab came to be. I cold called a professor at a private university in Delaware, Ohio, and said, hey, can I rent a lab? And he's like, no, we've never done this. University's like 200 years old. We've never done it. But he was a computational chemist. I helped him clean out all of his computers because he was a computer hoarder and used his chemistry lab because every professor there got a lab that wasn't a teaching lab, so wasn't used for students. Cleaned out the lab. My wife actually helped me paint the lab, first lab. Now we have about 5 labs at the university, Ohio Wesleyan University in Delaware, Ohio, and you'll see kind of who we have. So like I do everything, proof of concept. Is this something I want to do? Is this something that can bring value to farmers? Can we move commercialization faster? Can we develop products faster by doing it ourselves? Can we connect with commercial industrial companies to give them what they want and because they already know the market, right? Everyone always asks me about arables, like, what's your next best idea? We don't have ideas. We don't try to predict commercial or industrial trends or consumer trends. We're engineers and chemists. We'll fail every time. So we're depending on commercial industrial companies. They already know what consumers want. They already know what industry wants. They're coming to us, giving us technical targets, and we're trying to develop a product for them. So that's a lot of background, but I have extra time.
Just real quick, just click.
Okay, or can I just do this? Okay, so a little background, because one of the top 5 of the Soy Innovation Centers was bioplastics. So I dug into kind of the history. I had a friend send me a journal article from like it was a plastic journal article from 1948, and it got me thinking. Plastic's been around, bioplastic time. Carver, Henry Ford, kind of the brainchilds of that. Henry Ford really pushed. There's even stories of him throwing a bag of soybeans down on the table and telling his scientists and inventors, hey, I want the entire car made out of soybeans, right? It's the kind of the story behind it. So bioplastic is not new. It's been around since the 40s, 48, 51. And I didn't go to that, but you can develop almost anything out of bioplastic. Anything that petroleum can be used for, you can use bioplastic. You just got to someone has to be able to sell it, someone has to be able to buy it, so the economics, technical targets have to be hit. So this was the journal I was talking about. 1946, 18% of plastic was bioplastic, mostly cellulosic. That's changed a lot. We have petroleum kind of boom. And so that changed quickly. From 1946 to 2010, we went to 0.4% bioplastic, right? It's not the best trend, but like I said, petroleum is a tough target to hit, right? And bioplastics, kind of got displaced, but it's been around. This isn't new, and we're kind of just revisiting it because consumers and industry we've learned a lot, like all the research that was just shown, which was a great presentation. And I don't always go to the conferences, and I get kind of geeked out, but that presentation before me, it just gets me excited about, what else can we do? And so, again, things are kind of changing again, and we've been seeing this. And you could pick bioplastics, you could pick biolubricants, you could pick any kind of application. This trend is going up in all these spaces. We're kind of testimony to that. The amount of commercial industrial companies that are coming to us. When we started Arable, I felt like we had to kind of beg people to get into this space. Now people are cold calling us. People are seeing some of the products we've developed, or some of the things the Soy Innovation Center at Illinois is doing, and we're getting attention, and soy's getting attention. Hopefully I'm holding this close enough. Everyone hearing me okay? Okay, sometimes I go fast. Market drivers, we've been working a little bit with the plant-based, let me get this right, Plant-Based Product Council, just trying to understand what kind of commercial companies are they kind of serving. They're about the same age as us, about 5, 6 years old. They work more in the policy side, but they do a lot of these consumer studies. So people are wanting, they want to reduce VOCs. That doesn't really change, but now they're being just, banned, right? EPA or other countries are banning some of these products. So PFAS is one of them. We get a lot of calls and a lot of attention around PFAS, even as simple as coatings for like a razor. right? Like your disposable razors have PFAS on them, right? Not to scare anyone, but they're disposable. They have a Teflon coating. Teflon's used for everything, or these type of fluorinated polymers are used for everything because they work great. So how can we develop some technologies? How can we develop soy-based technologies that can match some of this performance? Because that's what the consumer's used to. So there's a lot of technical challenges ahead. I think we can do it. Just some more market things. Bio-based resin market, growing. It's a great area to get into with kind of this spring. I have to get my SpringBoard challenge. I think it's a great area. And it's a little bit to my background, which I get really interested. USDA, I won't go through this, but bio-based market is growing. It's very important to the United States. We've seen it for the last 5 years when we started Arable, a lot of value chain problems. I would say 1 every 2 clients that we started working with had some value chain problems. They could not, that's one example is like a phosphorus. They could not get phosphorus-based materials because of through Asia or other problems with value chain or material challenges. A lot of projects we started was because of these value chain problems. So how can we produce things in the US? How can we use things that are in the US to manufacture, whether it's bioplastics, whether it's lubricants, and so on. So there's a lot more to be done. I love if you didn't catch it, you know, of course, Henry Ford's the champion. I kind of think of maybe the Soy Innovation Center as the champion, you know, pushing. But there's always the technical people, and that's who they're looking for, right? As John Patton is in the background, see him in the window. He's the one that actually developed a lot of these bioplastics, soy-based polymers. So he's sitting in the background, kind of in the shadows, but I think it takes a team, just need very similar type actors. Goodyear, I think that was mentioned. I was trying to connect cars, tires, so Arable didn't have any part in that. I think U.S. soybean farmers did, check traction control. So I think things like this over the years have really improved consumer perception, industry consumer perception. Folks tried bio-based in the past, a lot of companies we work with, and they didn't work, or they weren't at the quality standards technically that we're seeing now. So I think having more of these brand name type companies get into the space and soybean farmers investing in them is just going to keep helping that trajectory increase. So who's Arable? We are a research, I say research and development because that's what everyone likes to say, but we're really a product development company. We do research and development. We're funded, so working at Battelle, it's a lot of echoing. Just lessons learned. So how do we incentivize commercial companies to get into the bio-based space? We're fully funded. So Illinois was the first funding partner. We were started by the highest soybean council, but Illinois is the first. Now we're 7 states fund our lab, and that allows us to do free, basically. There's some ways of doing that, but there's free research for commercial and industrial companies. So if a commercial company or an industrial company comes to us with technical targets and they understand what their client needs and it's the right people in the room, we'll start a project with them. It doesn't cost them anything. We typically will protect the intellectual property, then we'll license it to them for their field of use. Once they commercialize it, there's a royalty be generated, then that royalty comes back to our lab. We're a nonprofit, just goes back into more research. So that's how we operate. And so far, so good. It's working fast, working well. I feel like we've developed at least 2x, 3 times the amount of products that we could have, maybe funding others to do this research. This is our history. We technically started in 2019, but that was like me and some temp service folks. Full launch, September 2021. Now we're about 10 salaried staff, so started hiring full-time people. We've got more scale-up space. We've doubled our budget. Now we're going to be opening a second lab at a university in Portsmouth, Ohio. And this is going to get us not only, so right now we're pretty much a wet chemistry lab. You know, we don't have polymer, the capabilities maybe in here. We don't have the injection molders, the extruders, but Shawnee State University does. And so we're building a lab, designing it, building a lab inside their university, a little more chemical engineering, a little more bio-industrial engineering. So we're going to be looking at fermentation and other processes. So we're getting a lot of clients. Just yesterday, I had a gentleman call me that had graduated from Shawnee State, and he runs a large business around PHA straws and cutlery, right? And so PHA, there's some value chain problems with that. It's very marine compostable. So how can you, I mean, this is a challenge. We're throwing out the bioplastics. How can you use soy to develop like a PHA type marine compostable type material? It's a huge need right now. Yeah, I'll get into like the why. You know, we're using farmers' money. I've always taken that very seriously. So how do we use it, take it things further? We can do probably 4 to 5 times the amount of research ourselves than funding others. Just that connecting with commercial industrial companies, us, and kind of in control of like doing proof of principle. We can also kill projects quickly because we're fully funded. If we don't think soy is a solution, or if there's a soy product already out there, we'll connect that company to other partners, to other companies. We'll just move on to the next project. We don't just get research funds. We don't just spend research funds if we don't think we can develop a product using soy. We can also start things as soon as we want, right? Literally, we've had client visits, and the next day we're starting on a project, whether it's surfactants, solvents, and other things. This is us right now. I do feel like we're not going to ever be too big. We'll have a lot more capabilities. That's the point of having another lab, not really to grow in numbers. You've seen a little bit of this. We're kind of looking at all parts of soybeans, whether co-products, the hulls. I mean, 20 years ago, I did a project on torrefication of hulls and looking at it in high-density polyethylene. We have one client that's looked at it for manure spreader boards, so like decking boards, but for manure spreader boards. How can you utilize the torrefication process to create value for the hulls? Or you could do it with a mill too. The hulls is a lower value co-product, but displacing that high density, or displacing, maybe not like these gentlemen were giving me a presentation in here. It's not really maybe compostable or biodegradable, but you are displacing an expensive petroleum-based material with a bio-based material or a co-product from agriculture. Generally, companies, I would say 90% of the time, are trying to displace petroleum. So most of the time we're starting with soybean oil, and we're buying epoxidized soybean oil. It's already available, or Kima, for example, and then we're acrylating it and then maybe functionalizing it, or doing some chemistry in the synthesis side to develop it specifically for our customer's application. I would say we're about 50-50. We're 50% of the work we do, our clients, are about formulation work, no synthesis, and roughly 50-60% is synthesis work. A lot of times it just takes longer, the synthesis, because if it's a new molecule, you got to go through you got to get a CAS number, you got to go TASCA regulatory. So that's a lot of the things we've learned over the last 5 years. A lot of the clients we have to handhold through that. Some of them have manufacturing capabilities and have teams to handle that, so those move faster. But we're trying really hard to figure out the value chain, how to get things done quicker and commercialize products faster. Yeah, so why do we do this? I mean, it's the same as Illinois, is creating value for farmers. You know, we're utilization of soybeans, that's number one for us. It's also capitalizing on checkoff funds and trying to maybe, when I grow up, I guess, or when Arable grows up, I would love to see half of our budget be from royalties and maybe half from checkoff. So how can we kind of do more research using checkoff funds? This is something we just were part of a deal. So a lot of our products will be in all the Do It Best stores. They have roughly 6,000 stores across the, and so that when you talk about volume, it starts adding up when you eat individual products. So we're pretty excited about that. We just found out that, and value to farmers, and reputation, right? And farmers can pick this up at the store, they can give it to their neighbor, they can, okay, hey, this is where your checkoff fund's going, this is, for example, the bar and chain oil, it's roughly 96% soy, right? Just last year, when it was launched in Home Depot, 60,000 bushel demand just for that one product with respect to oil. Another product we developed is a rejuvenator, or something to use on asphalt roofs. So as your asphalt roofs age, something to apply to prevent from going in the landfills, but also extend the life. So we're pretty proud of this, just because that was very early for Arable. This company was a startup. I believe they're valued at about $200 million company, 420 dealers throughout the U.S., and I look at those as 420 businesses throughout the U.S. Some of these dealers are generating $1 to $2 million of revenue, which is pretty impressive for one soy-based tech product that created this business. So we're pretty, at least I'm very proud of that. Bar and chain oil, I already talked about it. I tried to convince every company to put our logo on it, their Highest Soybean Council logo on it. For whatever reason, very early on, maybe 4 years ago, I was like, hey, can we slap a Highest Soybean Council logo on it? And they said yes. So hopefully they'll keep it on there. A lot of companies don't always go for that, but we're pretty proud of it. I think the advantage of working with maybe commercial industrial companies, this is just one example, is Stanley Black & Decker, they're selling tools, right? The first non-tool products that they're a part of, and when people are going in and buying tools, these bar and chain oil is setting by the tools. It's not setting in the row of other bar and chain oils, right, and competing with other bar and chain oils. So number one on Amazon, and it's selling great on Home Depot. Greece, Illinois mentioned this. I think this is a really good example of a partnership between the Soy Innovation Center and Arable. Is we helped them develop it, and they're the commercial partner. So Todd licensed this, or the Soy Innovation Center licensed this from Arable, and really are in control of commercializing it, connecting with companies that we don't know. Or did we have contacts with, and really taking it maybe, like you said, the 11th hour and taking it to the finish line. So we're excited to see this keep going. We're excited about the field trial that I've just heard about, and however we can help. Oil and gas is another area that we spend a lot of time in. We've licensed 3 technologies. So lubricant and non-FOSS, it's kind of to the story. Scale inhibitor for downhole oil and gas. And I think the genius part of Arable is, I didn't really know at the time, is the non-FOSS scale inhibitor that we patented. We licensed it at LFS Chemistry out of Texas. We're talking to 3 or 4 other companies. Same chemistry, but for different applications, whether it's laundry care or water towers or boilers or water treatment. We're seeing very good promise within those areas. So checkoff money spent, they spent more than $1. Spent $1, develop a technology, and that technology is going to go to 4 or 5 different partners within their field of use, as long as they're not competing against each other. I've talked about this. This is how we work. It's working so far. We're pretty flexible. That's the part about the small IP flexible. If we have large manufacturers come to us, and they're potential large volumes, we have no problem handing over the IP to them. We tend, with small mid-sized companies, we tend to hold on to the IP because we're not sure if they can take it to market, and we don't want to lose control of that IP. But if we have large manufacturing companies, and you could start naming them on top of your head, that's the nice thing about Arable. We're nonprofit. We're trying to create demand. We'll hand over IP if we think that can help them produce commercial products, create large demands that we're looking for. A little bit of a processing lab. We're excited. This will open fall 2026. We're already going after a joint DOE grant with Battelle. And so around this whole capability of fermentation, bioindustrial engineering, and then also utilizing university engineering department. They'll utilize our equipment. It's kind of how we do at Ohio Wesleyan. They have all the analytical equipment. We hire interns, we hire students. So it's created a lot of value for the university. We're trying to do the same thing at this university. Yeah, that's all I got. Hopefully about 12 products just in the DeWalt brand by the end of the year. The bar and chain oil was the first. Trimmer, like a bush trimmer, is out next. It's kind of a hybrid between the bar and chain oil and our multi-use oil that we developed, and so on. So I think starting out really well, I think it's helped us and kind of propelled us. We have other brands that are going to carry some of these same products, maybe private label brands. But yeah, that's all I got.
Okay, we're going to take a little break to about maybe about 5 of. I'd encourage you all, if you haven't had a chance, to go look at the displays that are set up there of some very interesting work that's being done. And I'm sure they'd be happy to talk to you about it. So thanks, everyone, and we'll reassemble in about half hour or so.
Test, test 1, 2, 3. 1, 2, 3. Test 1, 2, 3. 1, 2. Test, test 1, 2, 3. 1, 2. Test 1, 2, 3. Testing 1, 2, 3. Testing, testing 1, 2, 3. 1, 2. Test 1, 2, 3. 1, 2. Test 1, 2, 3. Testing 1, 2, 3. 1, 2, 3. Testing 1, 2, 3. Testing 1, 2, 3. 1, 2. Testing 1, 2, 3. 1, 2. 1, 2, 3. Testing 1, 2. 1, 2, 3. 1, 2. 1, 2, 3. Testing, testing 1, 2, 3. 1, 2. 1, 2, 3. Testing 1, 2, 3. 4, 5, 6. Test 1, 2, 3. 1, 2, 3. Testing, testing 1, 2, 3. Test 1, 2, 3. 1, 2. One, two. Test, test 1, 2, 3. 1, 2. 1, 2. 1, 2, 3. 1, 2. Test 1, 2, 3. 1, 2, 3, 4, 5, 6. Test 1, 2, 3. 1, 2, 3. 1, 2, 3. Test, test 1, 2, 3. 1, 2, 3. 1, 2, 3. Testing 1, 2, 3. 1, 2. Testing 1, 2, 3. Testing 1, 2. 1, 2, 3. 4, 5, 6. Test, test 1, 2. 1, 2, 3. 1, 2, 3. Testing. 1, 2, 3. 1, 2, 3. 1, 2. Test. Test. 1, 2. Testing. Testing. 1, 2. 1, 2, 3. Test 1, 2, 3. 1, 2. 1, 2, 3. Testing. 1, 2. 1, 2. Testing. 1, 2. 1, 2, 3. 4, 5, 6. Test. Test 1, 2, 3. 1, 2. 1, 2, 3. Testing. Testing. 1, 2, 3. 4, 5, 6.
5 minutes, 5 minutes.
Okay, folks, we're going to get started. So if everybody could find their chairs.
Hi, everybody. I'm Victoria Harmon with VL Harmon Advisors. I've been working with ISA on SpringBoard Challenge and launching the Innovation Center. And I would like to bring my panelists up here, which is John Anderson, President and founder of Greenleaf Advisors, Aaron Amstutz, Chief Scientist at NFW, and Pat Killian, CEO of Veredus Chemical. You can come up here and then I'll sort of lay out what we're going to be doing here this afternoon. So, you get the middle. This is going to be very free-flowing. We're not going to do any PowerPoint. We're going to be talking in conversational form. I hope to also leave a couple, few minutes for some Q&A potentially from the audience here. So, what we're talking about as our first roundtable today is to discuss opportunities for soy. So we're playing off what we've been hearing all afternoon. So our panel right here is going to share some early models for soy-based innovation, which is all part of a bigger vision here, positioning Illinois as the global capital of ag tech, following on what Todd said, where we want to create a sustainable planet. And these folks on my panel are going to have been doing that. And what we know is ISA isn't just talking about this future, they're actively investing in it. And through the Soy Innovation Center, the goal is to support and prime the pump for innovation, commercialization, and scaling products, and deploying materials which are also sustainable. This roundtable is about fueling the exploration of soy's potential in material science, chemistry, manufacturing, and the real world. Basically, how to generate real market traction, measure economic return with solutions that could also benefit entire communities such as in Illinois and around Peoria. Basically putting all the pieces together for a puzzle to create an ag tech economy. So what I hope you all walk away with today is a deeper understanding of what it actually takes to commercialize sustainable innovation from soy, build high performance products that people want, and make regional investment decisions that not only deliver business value, but also benefit our farmers, their families, and the broader economy. So today, we hope to set the tone for that vision with this roundtable. And each of our speakers here brings firsthand diverse insight into that journey from science to scale. And from that, I'm going to turn over. I would like each of them to introduce themselves. I find that when I just read people's bios, we all just glaze over. So, and we've all got such deep careers, there's always just the relevance of what we're doing here today. So I'll start to my immediate right, Aaron.
All right. Yeah, I'm Aaron Amstutz. I started with Caterpillar right out of school. Was with CAP for 17 years. Now been with NFW for over 8 years. NFW, formerly known as Natural Fiber Welding, is a material science development materials company making stuff here in Peoria. Soybean oil or epoxidized soybean oil is one of our inputs. We make various polymers. I brought some samples. Our highest value product that we're making in Peoria is called Mirum. It's an alternative leather-like material, and we make that over here by the Ball Diamond on Jefferson Street on a $30 million manufacturing line.
And over to you, Pat.
Okay. Hi, I'm Pat Killian. I'm a chemical industry guy. I spent about 10 years in refining and petrochemicals, and then about 10 years in global specialty chemicals with two companies, Roman Haas, and then they were acquired by Dow. And then I spent the last 10 years working with private equity and private family-owned companies, much of that working on strategy or serving as an interim executive or business leader, taking things into and out of transactions and acquisitions, things like that. I joined Veredus Chemical a year ago, and let me quickly tell you about Veredus. Our intention is we have a portfolio of IP to make a variety of solvents and intermediates, liquid chemicals from renewable corn-based ethanol. I was told that there's no animosity between the corn and soy people, but I'll tell you, no soybeans are harmed in the making of our product. So these are metal catalyst continuous processes, which also makes us a little bit of a curveball in this group, this ecosystem that we're so happy to come and join here in Peoria and have been warmly embraced by some of you already. But our big news is we are actually moving our plant from Nebraska to Peoria. Just south of downtown here, we're leasing land and have a long-term supply agreement from BioUrja, which is the old ADM plant. Before that, the Hiram Walker whiskey distilleries. And people have moved plants before, but we're doing this very quickly. It will be up and running by the end of the year and making sales in February. And the plant is huge. The other way we're a little bit different in this community is our plant, ethyl acetate is a common solvent used in a variety of inks, adhesives, coatings. I always say you may have a bottle of it under your sink as nail polish remover. So the market is large and it's there. We're the only renewable manufacturer in the US, in the Western Hemisphere, and our plant is actually the biggest in the US. We're bigger than the hydrocarbon guys. 120 million pounds a year. Our smallest product package size is full truck, 40,000 pounds. And we're moving the whole darn thing here to Peoria, piece by piece.
Let's give a hand for that one. So John, how do you advise companies on how to do this? Go ahead.
So I'm John Anderson with Greenleaf Advisors. I founded that after helping build a company called LaSalle Partners into Jones Lang LaSalle, JLL. You might have heard of that. Spent 18 years there in the 80s and 90s after a banking career, by the way. So I come at it from a finance and economic perspective. Our mission is to advance a healthy and sustainable world. I actually also worked at the Nature Conservancy Direct Program. So the board of Greenleaf includes leaders across the board in the business and natural environment. I was talking to some scientists recently. Really, everything that underlays our business is sound science, advanced policy and business solutions. And we do that on climate, land, resource protection, you name it. So we're here on the material side to help advance, move the pile on sustainable products. One colleague is here, Katie DeMuro. Ben Bizart couldn't come here. If you've heard of Cradle to Cradle Institute, that's really a leader in certifying sustainable products. Ben onboarded, I think, 600 companies into that before joining us. So we have some expertise in the protocols for getting things certified, being sustainable. It's one of our roles. We had a first phase assignment with the Innovation Center. And I guess my role is going to be, by the way, I helped to relocate a bunch of companies, manufacturing plants, headquarters across the country in Asia, set up a business in China. I know more than I want to know about what's going on in the world in terms of the stresses. I was asked to say why I'm here. I've got two granddaughters. I gave my first talk on climate change in 1997. Don Webbles is on my board. He's led every client assessment, not led them all, but led the fourth assessment for the US. I know more than I want to know about the stress, folks, on our water supplies too. So we don't talk about that very often, but that's what drives my business ecosystem, my partners. Delighted to help any way I can commercialize sustainable products. And we've done it a little bit over the last 20 years at Greenleaf. Wakefield Biochar is a client of ours. It's now one of the leaders. I could go on and on, I won't. But if we can help you in the business ecosystem, commercialize truly sustainable products, please call Greenleaf Advisors and we'll do that. Thank you.
Thanks. And also, I should probably give a little background about myself. Thanks for that, John. I come to this, I'm actually based in New York and Los Angeles at this point. And I come from understanding the energy policy system and sustainability. I worked for the governor of New York for about 10 years, and now I'm advising companies and organizations such as ISA and energy and utilities on how to break down barriers, whether they're financing barriers or policy barriers, on how we can get to a more sustainable future. And as building on what you said, it's an entire ecosystem. So this is, I'm getting to know the agriculture, ag tech part of it from the utility part, who's done this, who's been doing this for a lot longer, the EV part of it, but it all fits together. We can't, everybody in this room has a role to play in the sustainable future. You just bring your best part of your ideas, innovations, and energy, so to speak, forward. and we can just sort of get through some of these really challenging times. I was at a conference last week in California where you had policy and energy and utilities and energy people all in the same room, all looking at the same world we're looking at, which is we can all, it's still we're still a nation states full of individuals with passion, with ability to innovate, and nothing's going to stop us from doing what we've been doing for the last 10 years. And I'm really great to be here, be part of that, and to see all these faces in the room who are going to help us get to a better future for our children, our grandchildren. So with that,
So if I could just say, you brought up energy, Victoria did, and biggest wedge of the climate pie, by the way. So we're actually turning on clean energy at grain elevators here in Illinois with backup power when they're unloading during the peak periods. There are all kinds of innovative ways to save money. Energy's better than everything, and we were talking about that a little bit earlier. So really understanding your energy footprint in the products, transportation, is central, and lots of solutions out there.
lots of solutions. So with that, thinking about how to, Pat, why don't we go back to you? Because you were really talking about, moving into Peoria. Let's dig a little more into that. You have made the decision to relocate, as you told us. You're investing in it. And why is Peoria? Why Peoria over Nebraska? Why at this time did you decide to do this quickly and make that financial, economic, and personnel commitment to locate here?
Sure. Well, our raw material is high purity ethanol. So we came to Whiskey City. We were aligned with BioUrgia. We were getting rail car supply from them. So we, coming here will significantly lower our costs, increase our reliability, our ability to make commitments to our customers. So that's a little bit of a different reason, but I think there's commonality. We're pulling on this incredible ethanol biochemical infrastructure, and the more diverse uses of those materials, not just more consumption, but the more diverse there are, is a common foundation of the hub that you guys are talking about trying to build, right? The other things that are very attractive to us about being in Peoria is the river. In our case, we'll go up to barge scale and having barge economics to access to the Europe market. I'm not a renewables background guy. I'm a chemical manufacturing and marketing guy. But my intention of the marketing plan of Viridis is one sentence. We're going to take our fair share of the big market, and we're going to take 100% of the renewable market. And we can help consumer goods manufacturers who want to make a big move in their carbon footprint. We can help them make a big move because we're selling them rail cars. Okay, this is not the eye of newt in the formulation of these inks and coatings and adhesives. But we can't help them if we aren't around. So we have to go out and compete. And in what I call non-differentiated products, right? We're selling it to a spec and competing with other people. Every tenth of a penny counts. And here in Illinois, you have attractive utility costs. You're sort of at a crossroads, which is much closer for us to demand. Barge economics to the Gulf, to the U.S. Gulf Coast, and then out to Europe. These are the things. All the great science can't happen if you aren't running, if you aren't profitable and you aren't running. And we plan to go out and take our share.
Sounds great. And now back to Aaron, as someone who's actually been in Illinois, and you've got some products in your lab, we'll have to talk about that eventually. What does it take to create and grow a manufacturing company here? And what would make it easier for the next generation of startups? And what advice would you give a not so newbie, but still new to the area person like Pat?
That's great questions. So I'll be unashamedly, I love Peoria. I grew up in Chicago suburbs. Go back, I hate the traffic. I love Peoria. 20 minutes anywhere, and we enjoy that. I've had no problem recruiting engineers to Peoria. With the low cost of living, we can be very competitive on salary. And as soon as they can see what kind of house they can get for that salary, we have no problem getting people to Peoria. So, I mean, we have a beautiful city, we have a great community. We also have a easy place to recruit people to. We don't have a whole lot of homegrown material scientists. We have some. Bradley University does a lot of good mechanical engineers and some good chemists. They don't have a material science department. I have to import those. But again, it's a great city to show off, and we have no problem growing here. We've got great support from the community in all things tied to government as we locate facilities for us. We've been at different places. We've been at Next Innovation Center. We were out at Industrial Road for a while. Now we're on Galena Road and kitty corner from the Ball Diamond, and had help in every one of those moves. So it's been a great partnership with the folks here.
And the Peoria Chamber of Commerce did not pay him to say any of that.
It's just really good.
John, so you've worked with a lot of companies like the two we have next to us. You've worked with a lot of the companies like the two we have next to us, across as you said, across different materials, water, energy, in the sustainability world. What do you see as the key conditions for successfully scaling bio-based businesses like we're talking about today, especially in the Midwest, in Illinois, to make this the ag tech capital of the world?
Well, one thing I'm reminded of is I went to a nanotechnology and water conference many years ago, early on when I was looking at the venture capital investments and support of these early stage companies, and someone got up and said, it's really 17 years before you know you're to be successful. And I said, 17 years? I mean, it takes persistence to really, there's a great book called Crossing the Chasm, cross the chasm, get into the mainstream of the marketplace. And I've witnessed that firsthand. We're managing a company that's crossed the chasm on optimizing energy storage right now, associated with solar, and turning it on with manufacturing plants, the grain elevators I mentioned, and so forth. But I've been 12 years working with them, okay? They were hanging their idea on IIT wall with some donated equipment when they pinged me after 2 years, said, can you help us? So I've seen a lot of early stage companies. By the way, having the technology isn't enough. So what a brilliant man came from Iran. He was one of the Shah's top scientists. He came here and he was looking to commercialize product, and the EPA called me after I left, JLL and then TNC, restarted Greenleaf in 2009, I guess, and they said, can you help us commercialize this business, John? And I said, he had the winning technology to clean up contaminated sediments on the Housatonic River in New Jersey. Wonderful man. Boy, we worked for a couple of years. And the EPA wouldn't sign the sole source contract to build a plant that would enable us to get the financing so they could ship all that, all the areas of concern, contaminated sediments, which was one of my missions when I was at TNC, so they could process it, put it back in the soil, and we couldn't dig it out of it. I could go on and on. So this wonderful man, Mohsen Amran, had that technology, went to U.S. Steel, and we were gonna recover their contaminated sludge. The technology didn't work on that one, it worked on the first. So, you've got to have the technology, you've got to have the contracts, you've got to get the capital, you've got to scale it, you've got to diversify your customer base, all the fundamental business characteristics, okay? I've worked with a number of early stage companies. Some have made it and some have not. Persistence, and I won't talk anymore, but it takes market, political approvals, capital, okay, infrastructure, environmental issues, basically the 5 main drivers that optimize land use when I was managing the land business across the country. You got to optimize all those issues to figure out how you're going to develop a piece of land into a tower or into a airport expansion and serve your client. You got to do the same thing in any business. It's kind of those 5 main drivers that we like to optimize, and these gentlemen are doing in their business right now.
Thank you.
And by the way, on the Midwest, let me just, I'm 68 next month. I was born to the son of a hurricane hunter in Jacksonville. He came back here. I was raised a banker. This place, the crossroads of the world, I know it super well. We are at the intersection of a lot of course, transportation, markets, no place better than, this metro region, Illinois, for innovating many industries. And we're at the global center of this continent for global trade, right? This gentleman was just talking about the shipping, but we're really blessed. Geography drives a lot of issues. Attracting talent, like you were mentioning, talent goes to quality of life. You've got quality of life here. Okay, it's a global talent, competition. The innovation that's happening here, I'm just learning more about. I was first here, it's a long time ago, late 70s, early 80s, financing things. But this place is a gem. The Midwest, climate change, last comment, I'll pass the mic. But looking at the climate risks around the world, I mean, with Earth Knowledge, we're forecasting climate stress in California and elsewhere. We're relatively resilient. We've got water supplies, land resources. We're blessed here with a resilient place for our communities. So we need to capitalize on that.
Totally agree with that. Just coming from, I just spent the last week in LA where the only talk was about how to rebuild the city after all the fires. You just can't even imagine. Spending most of my time in New York, and so the resilience factor is real. And when you have a disaster that takes out so much money and so many people, everything comes to a standstill until you can figure out how to bring it all back. So thanks for reminding us of all that. Pat, you were talking about how you did not want, you did not go into this to build a sustainable business, renewables, but it's just something that has come out of this. But at this point, how does that overall sustainability factor into your overall business value through certifications, what customers want, pull, long-term ROI? And then I have a follow-up after that is, do the farmers, in terms of your moving here, the Peoria and the innovation of the farmers and how productive they've been, did that play a role also in your moving to this region?
Well, let me clarify what I intended to say. My background is not renewable chemistry. Viridis exists. It was founded to make solvents and intermediates from renewable ethanol. But my belief is the way we succeed in that is by existing. And when you have the biggest plant on the block that's continuous, we have to run flat out. We have to run full, and we have to be economic. We have to go out and compete. And that allows us to be a sustainability, leader. The market for mandated renewable ethyl acetate is nascent, but it's happening. We've had requests for quote for guaranteed renewable ethyl acetate in the U.S. and Europe, but it's not enough to fill our plant. So that's why I say we're going to take our share of the big market, and then we're going to take that too. And being here allows us to have the economics and just the success factors to do that. Again, for your second question, if I understood it, farmers, we're not going to be interacting with farmers. We're a step away from them. But what many people like the folks at the USDA that I met with recently and others are excited about is we're pulling on this hugely developed infrastructure around corn to ethanol. And the more that can be diversified away from gasoline, everybody is very excited about. And that's our participation. I have been in this job for a year. A couple of times I've been to renewable chemistry and fuel conferences, and it's just a fascinating array of technologies. And we're making plastic out of pecan shells and something out of corn stalks. And I leave those thinking how relieved I am that I'm connected to ethanol, because I don't want to go around and collect pecan shells, and the infrastructure is here. The infrastructure exists, but it's here in Peoria too. And so it's the easy button for us. We think it's a great raw material. We think it's at a good value, and it's abundantly available for us to go out and make a big difference in the carbon footprint of our customers who make consumer goods. Did I address what you were asking?
You did. Thank you.
So farmers may or may not ever hear the word Viridis. I don't know. But we're pulling on the end of that.
Right. Aaron, I just have to ask, what's on your lap?
I always bring show and tell. This is an elastomer that is linearized epoxidized soybean oil citric acid polymer. So one of the challenges in designing renewable polymers is figuring out what they're good for. And there's a lot of people who have been trying to make soybean plastics. Unfortunately, most of those are pretty crappy because the TGs are wrong. It's actually easier, it's a rubbery material. It's easier to be in the rubbery space than try to be in the plastic space. And so this was an attempt to say, what's the most economical way that I can make an elastomer with soybean oil as an input? And soybean oil as an input, as many are aware of the chemistry, you've got double bonds to deal with. You can't do a whole lot with double bonds, but epoxidized soybean oil is available at scale. Railcar loadings of ESO is sold as a plasticizer to the PVC industry. So we leveraged that scale. And then among the other things you could do with that ESO, you can cure it with citric acid, which is also available at railcar levels of scale, food industry. So we looked for two inputs that were available at scale, 100% renewable, and then what can I do with that to make something interesting? And plastics were not on the table, but elastomers were. And so this was a way to, we have patents on this, but it was a way to make an elastomer with two railcar available natural inputs, so we have 100% biogenic carbon at the end of the day. And so anyway, that's what this is. And then we do some clever chemistry to figure out how to actually make something that has some tensile strength and some processing and some good mechanical properties. And that's some know-how and some patents. And anyway, that's what this is.
And what's this?
Okay, this is
Gotta-
what...
and this is it, I'm close
Yeah,
up.
this is good. This is the first prototype from a line that BMW is developing for their new electric vehicle, using our Mirum, which uses the soybean oil curative technology, and we've done some other things that are interesting. Let me just say real quickly, our place in the market here is a little bit different than other biomaterial companies. We took a stance early on that we were not going to use any petrochemicals at all. So there's a lot of people that will be 98%, 99% even biogenic carbon, but then you have to protect it from ozone and oxidation and light. And so they'll throw in some sort of molecule that protects from those things. Unfortunately, those are the things that bloom to the surface. They come to the surface to protect the surface. Those things are the things that your body interacts with, and those are the things that are potentially toxic long term. So you're not solving the hard problem until you solve the problem of the additives. It's not good enough to be 98%. You have to get to no nasties. And so for the last 3.5, 4 years, for those of you in Peoria who followed our journey, like, why is it taking so long? Because solving those problems is really, really hard. So we screened hundreds of natural vitamins. Everything that you can find in a health supplement store is on my shelf in the lab. We screened every health supplement, every vitamin, every mineral, things that Dave has modified for us at Midwest Bioprocessing, thank you. And we found ways to protect natural polymers with natural molecules. And so that's our claim to fame and what we have drawn the line in the sand in, and that's why we've commanded the attention that we command, because we're the only people in the world who've said, this is what we will do, what no one else is doing.
And a follow-up to that. So the Soy Innovation Center has been around for a little bit over a year now. ISA is making this big charge into this world that you've been in. What gets you excited about potentially, teaming up and having this new resource for you?
Yeah, what's exciting for me is right now to get them the full properties that I need here, I'm actually using a fair amount of natural rubber. So natural rubber, I mean, let's be honest, most of that's going to come from Southeast Asia right now. There are people that are growing dandelions to get dandelion latex, and I'm rooting for them. I want them to be successful, and there are people that are growing waiuli down in the desert Southwest in Arizona. I'm rooting for them too, but anyway, today to get all the mechanical properties, we have to use natural rubber that comes from Asia. What I'm excited for is 10 years down the road, I'm hoping someone from Arable will make me the enolate of epoxidized soybean oil fatty acid that actually gives me a biopolymer that's got decent mechanical properties and all the things that I need to make a killer natural polymer that's all grown here. I think that's just time and good science, but I think molecularly it should be possible. And so that's what makes me excited, is to see the research. Again, I think in 10, 15 years, we'll have those polymers available and we can go head to head against the other natural polymers that exist.
And back to you, John. As someone who's advising and helping those invest and start in this business, in this sector, what gets you excited about? You've been, same with me, you've been working with ISA closely. What is with your years in the business and doing what you've been doing and advising companies and such, how do you see ISA playing a big role in what we're trying to accomplish here?
Well, I want to build off the last comment because I'm a big believer in distributed network solutions. In fact, there's an international research conference taking place in June, and we're speaking at it. I've got a panel on that. And again, it's distributed network solutions, water, energy, materials, so forth. So I love your comment because part of my motivation is to live more locally. I could cite some books. Some of you guys have probably read Small is Beautiful. What a cool book that is, right? Going back 50 years or something. But the point is, if we can go where you're going, all over the world, by the way, and live off our local resources with best world knowledge, but, source, manufacture, recycle, reuse in these local regional ecosystems with global knowledge, I think we live on a much healthier planet, okay? That's what drives me. So I think it is, though, about global knowledge, folks. It is about the best brains sharing it, but then, doesn't take a brilliant scientist to know that there's a lot of waste and distribution of things. There's a lot of cost, resource cost, human cost. We ought to be spending our time living holistically, locally. And then, I've burned more fossil fuel than I want to think of on a plane when I was leading our stuff in Asia. I purposely don't travel. I want my grandchildren, my family to travel, but ultimately we'll have, of course, non-fossil based fuel somehow transfer. But we just need to live more locally. So that would be my celebration of your last comment. And I think that, as I mentioned earlier, we're fortunate in North America, in this temperate zone, this climate, land, water, material, energy, climate. That's what drives us. We've got expertise in all of that. Land, water, material, energy, and climate. How do we optimize those resources, those earth systems, to live a healthy, thriving life, but a restorative one? I think there's great business opportunity that I think that companies that drive sustainable solutions will outcompete the rest. This isn't new, but it's finally being manifested, okay? They're gonna, in this wonderful competitive world, crowd out the rest for all the stakeholders that will reward you for what you're doing. Hats off to you.
Thank you for that. I love the passion I'm keeping it down a little bit, but I'm with you on all of this.
I'm actually keeping it down for me, for the people that know me.
Yeah. Let's see. So I'm thinking, Pat, in terms of what we've been listening to, and how you're joining Illinois to help it become the next leader of ag tech. What am I thinking in terms of what would you tell companies, as you're going out, and what you've been seeing already as you're at this conference and getting to know, how would you convince other, similar but different companies to say, Illinois, leave your state, come here, beyond what we've already been hearing? Is there anything new, anything different?
Yeah, I was thinking about this driving over to Peoria today. I don't know if it's that I'd go out and convince companies, but I have two thoughts. One is we've been just so delighted and blown away by the warm embrace here in Peoria. Chris and the team here has helped us in so many ways, big and small. Restaurant recommendations, helping set up training, introducing me to the USDA, and they were so excited when we went over and talked there. Maybe some of the USDA folks crestfallen that we're not doing fermentation, but Evan was certainly happy to hear about what we were doing. So I think just the size and the energy level of this ecosystem that you don't have to go find. I mean, it's right there, and even the city council and city management and the various departments helping us with permitting and things like this. It's been just right there to greet us and help us do everything the right way, because we're trying to do something very correctly and safely, but quickly. The other thing I was thinking when I was driving here of an analogy of something else that I worked on earlier in my career. About 20 years ago, I was developing and negotiating a joint venture in Saudi Arabia to make a group of specialty chemicals, acrylic monomers that go into coatings and adhesives. And this was, at the time, sort of the furthest downstream thing that they had done in Saudi. There's an area there called Jubail that's just a huge global scale hub of refining petrochemicals and plastic pellets. And that's about as sexy as it got then. And we were coming there to make a mere, 300,000 metric tons a year, which was tiny for them. And we didn't fit into the infrastructure. We said, how are we going to get our rail cars and trucks in and out? And they said, the what now? I mean, you just have a big 12-inch pipe that takes it out to the boats. And in many ways, we had to work with the ministries there to be that vanguard of the infrastructure. And we use that word, we all have kind of a prejudice in our mind of what infrastructure means, highways or power lines or something. But in this case, it was almost the commercial infrastructure of where the import and export offices set up to handle our kind of, materials, the security, things like that. And so I'm finding that a little bit here, that we're kind of, it's set up for a bigger scale, whatever Caterpillar does, corn, ethanol, and there's certain kind of economic infrastructure things that I suspect the fifth company doing what Viridis is doing, everybody will be used to it. And this is, you guys could probably help me think of other things, but talent, so, chemists, lab techs, operators, and the craft, or contractor support for certain things that we do that aren't that common here. Even how we want to use the river. We're not going to be 2 barges a day. We're going to be, smaller scale, different infrastructure for there. That was on my mind, that there's, we're kind of with our partners in the city, kind of crafting a new way there that I think is worth thinking about. Folks that come after us that are even smaller scale, but commercial scale, bigger than your scale, Dave, but that bulk scale. What do they need to get in and out of the city? What do they need to run their plants?
Yeah, you make a very good point. I mean, I was just hearing that the reason why we couldn't get to the food trucks today is because Caterpillar's having its 100th birthday or something, and Caterpillar broke down a lot of the barriers and created this ecosystem that you're now able to benefit from, and then other companies after you, as you were saying. It's not just it's policy barriers, it's infrastructure barriers, it's all the above, and you have to have a community, a city, elected officials, policymakers who understand this, as well as the people who write the check for you and your investors and your workers. So really good points there. We are at challenging times. We're sort of at a crossroads, and at a so to speak, crossroads of location, crossroads of policy, crossroads of a number of things. Back to you, Aaron. If we were here 10 years from now, or just 5 years from now, 10 years is so far away, what would you like to see? What are the people in the room? What would you like to see us talking about in terms of on the scientific and discovery innovation level?
Yeah, good question. As I mentioned earlier, one of the challenges that we've had is at the additive level, the little things that you have to add to polymers to make them work, processing aids, anti-degradants, that type of thing. Today, I mentioned that on my shelf at work, I've got all these different health supplements, all these vitamins and minerals and natural materials. Most of those natural materials today at scale are made via petrochemical synthetic processes. You know, your multivitamin that you take in the morning, most of that, even though they're biomolecules, they're found in living systems, they're made via petrochemical routes. Most of those petrochemicals are coming from China today. This is the reality. Your multivitamin is mostly synthetic materials coming from China that are made to mimic natural materials. Where I see the future is precision fermentation, making most of those in the future. So today I can have something that's got all biomolecules in it, but maybe 98% biocarbon. In the future, precision fermentation will allow me to have all those biomolecules at scale, all biologically produced. And that's what I'm hoping for, is where we can have all of those made locally, if we have a fermentation hub, and also all biocarbon.
And John, I'll turn that question over to you, and then if we have time, I'd love to open it up to some Q&A from the audience, since you've got such an esteemed, professional, well-established panel up here. But John, what do you see us 5 to 10 years from now?
I'm going to turn it back into a question because some of the folks I work with on one of our businesses are deep into artificial intelligence. And of course, that's in the press all the time. But I'm wondering how people are utilizing it in their business today. It's really going to revolutionize. It's been underway for some time, but it's accelerating innovation, accelerating change. I see it in our energy business. And I've got some board members that talk about it all. That's all they do is go to AI conferences. So I'm kind of curious, from your perspectives, how do you see it benefiting innovation on mission in your practice? And I'd be curious to invite comments from the audience too, because we've got a lot of people out here that probably have some great insights into that.
Yeah, if you don't mind, I can say for NFW, about 3 years ago, we changed from a recipe management. We were using Excel spreadsheets. We bought a cloud-based solution that allows us to manage and structure all of our data. And they have embedded AI tools so that it can look at my last 7,000 recipes and say, hey, you want to optimize around this parameter, and it looks just at my data set and suggests here are some starting recipes. Or, if you write this recipe, this is what you can expect to get from that, and then it will look at deviation from the expected results from what you actually measure. So that's where AI is impacting us at the material development level right now. It's at the edges. It's not coming up with brand new things, but as long as you have good structured data, it's able to interpret maybe beyond the 3 or 4 factors that a good engineer can keep in their brain at once. It might look at 5 or 6 or 7 factors and be able to extrapolate things that you didn't see.
Pat, are you bringing AI to Peoria?
Pass. It's not a focus of mine right now. I'm focused on safely moving this plan on time and on budget, but in the future, it's certainly interesting to read about.
Totally.
I get it. It's not a focus on mine either. It's my colleagues' focus. Anybody else want to share any, though, key insight into how they're using AI today that might be relevant? Because I expect some of you are, and I'd be interested.
Well, yeah.
I think same comment. As Patrick, the structure property relationships between new molecules haven't been done, pulling from literature of what maybe things that are close to in the vicinity, but helping get closer to the new molecules. We're just starting. How to do it.
Dusty? Okay. Don't want to give anything away.
I was going to say, we're doing a project funded by the One of Soy, and we're looking at optimizing the process. So, design of experiment software that's useful for, you've got multiple parameters, you data sets and results, and it will correlate results and say, hey, these two factors are really important, these two factors work against each other, and it kind of builds a 3D contour of go this way and you'll optimize your process, go this way and you're just wasting your time. And so it like very quickly allows you to kind of put yourself on the right track and spend less time, less experience.
And why don't you just tell us what you do for a living?
I'm a scientist at Midwest Bioprocessing Center, so we're using it for extracting sugars out of the soy hulls that are basically waste and converting that to xylitol.
Thank you for that, been very relevant. Any other questions? Oh, I'm getting the wrap up. We got to wrap, oh, we got one more question, and then we'll wrap it up.
Thanks, John Anderson, for your belief in circular bioeconomy, which we call safe for nature. And regarding your citric acid, just one comment. In Ag Lab, about 9 years ago, we did Wrigley chewing gum. They supported our research. Kevin Lu was the principal. About chewing gum in citric acid epoxy, soybean oil.
I know I had to get around his patent.
And 4 months ago, we published one interesting work on citric acid epoxy. That's all. Thank you.
Thank you. So I want to thank everybody, Pat, John, Aaron, on our panel today. Got some very different, diverse insights, but all on the same path to Peoria, Illinois as the ag tech capital of the world. Innovation is where it's at. And if you're not here, you need to be. Thank you so much for that.
Check. All right. We're going to keep the train on schedule here. The next panel we call State of Play, and we'll talk about why it is called that and who are here. We'll invite our panelists, David, Jen, Dusty, and Marty. Where's Marty? All right. All right. All right, we'll get started here. Well, thank you to all of you for coming here. You know, the focus of this panel, folks in the back, if you could please settle down a little bit. All right. See, the focus of this panel is to really dive into folks that are in the process of building various businesses. In the previous panel, you saw folks that have kind of been on the journey for a little bit. They're talking about train car loads and barge loads. And these folks, I would imagine, in 1 to 3 years, if you let their imaginations run wild, they are shipping stuff in train car loads. At the moment, it is in a lab or in a small scale, but still solving some very interesting problems and very relevant to the world of bioprocessing and biopolymers and so on. So my name is Badri, and before I get any further, I want to stop and thank the folks who were responsible for me being here today. I did not know a lick about agriculture or ag tech no more than 5 years ago. I come from the world of high tech. And I did study textile engineering 430 years ago, something like that. But I built a software company, exited that 5 years ago, and ran into Steve Pitstick, who is on the board of the Illinois Soybean Association, who introduced me to Todd. And the journey has been nothing but a great joy and a great learning experience. And so thank you to the folks who paved the way for me to be here and the folks here who still educate me every single day. So I'll just we'll go down the line and have the folks here introduce themselves more about what brought you to this point of meeting the Illinois Soybean Association, and then we'll go into what you do today. So walk us through who you were before you ran into the Illinois Soybean Association. Go ahead.
Good afternoon, everyone. Madi Vaezi, Associate Professor in the Department of Engineering Technology at Northern Illinois University. That little table set up to the left, see in this hall, that's us. I'm representing a big research team at NIU. So basically, we are NIU's bioplastic lab. What we do is everything from synthesizing in collaboration with Department of Chemistry to production and manufacturing and testing to marketing in collaboration with Department of Marketing. Even we do mold design and fabrication in the College of Engineering and Engineering Technology. A little bit of background on this bioplastics lab. So when I took over this lab from my colleague, Dr. Robert Totara, a couple of years ago, we rebranded it to Bioplastics. That's been serving as plastics labs for over 30 years now. Some of the machineries that we have in the lab goes back to 70s and 80s, in fact. But then since we started rebranding and now it's NIU's Bioplastic Lab, we have been mostly focused on incorporating agricultural byproducts and forestry byproducts into plastics and bioplastics. We were first approached by a dispensary located near O'Hare. So they were complaining about huge amount of waste they received and they are not willing to pay to the city and to landfill to get rid of it. So they said, what can we do with this? So within over something about a year and a half, we came up with several recipes for them to turn those byproducts into value-added products. So you can see examples right on the tables. Some of those are actually actual mechanical parts that are being mass-produced right now. And then later on, when we were working on hemp, so we developed some side ideas like, okay, we are using hemp as a filler and also some as a reinforcement, but then this is not 100% biodegradable because we are using it like fossil fuel-based polymers and hemp and some sort of additives, whether natural or synthesized additive, but how about making it 100% biodegradable? Then we started looking into, well, let's start with food packaging. PLA, PHA, PHP integrated with hemp fibers as filler reinforcement. We made samples, we tested, they came out very promising in terms of water vapor transmission rate and oxygen transmission rate. Recently, we have been working with USDA in a project to produce packaging for specialty crops. So there was this call by USDA, came out, I think, last year in December. They wanted proposals due in 1 year only, like project finished 0 to 100 in 1 year because they are facing issues, immediate issues to address. UK, EU, Japan, and Canada are not accepting single-use plastics that we use to export our food products any longer. So they wanted to get this fixed in 1 year. And we started working with USDA. Then we were introduced to Illinois Soybean Association, and then we figured out, well, here is soy protein. We started working on. I had a couple of meetings with a battery, so he wanted to find some use for these proteins that Illinois Soybean Association is working with, and we teamed up, started making samples and tested samples. Very promising preliminary results. We're about to start a 7-month to probably 1 year project with Illinois Soybean Association to produce soy protein-based utensil, but then we can incorporate 60 to 90% soy protein into those soy protein-based products with very promising mechanical and chemical properties, and everything is 100% biodegradable. We are other interesting projects going on that I can talk about it later.
the vision of the soy-based utensil is, these days people add protein to everything. So if you order soup and you stir the soup with a soy-based spoon, the spoon becomes the soup, and then you take, no, I'm kidding. Go on to the next one. On button and tap.
Yeah, hi. My name's David Demergen. I am CEO of Zoochem, and it's president of its spinoff company, Midwest Bioprocessing Center. We're located over at the Peoria Next Innovation Center. We initially started as collaboration with USDA Labs here in Peoria. Just a little bit of my background. My undergraduate was from University of Michigan, PhD from University of Chicago. And I set up my first company as a result of my as my PhD work. It was a company developing enzymes for food applications, including high fructose corn syrup, and for pharmaceutical applications. We got acquired in 2000 by Medichem Life Sciences. They were a contract research organization for the pharma industry. We took that public, and then when that was sold, I set up Zoochem here in Peoria. The first company was up in Chicago, and have been down in Peoria ever since with my companies building things. At Midwest Bioprocessing Center, we first started working with soy when we licensed in the technology from USDA for a product we call Ferula Shield, which is it's a cosmetic ingredient that's used as a SPF booster. So if you ever put on the sunscreen and you get that white pasty zinc oxide on your skin and you can't get rid of the white color, our product allows you to reduce that and boost the SPF. So that it can be quite high, quite good, and you don't have quite the same level of white cast on your skin. That's been commercialized now, and it's growing in a couple dozen different sunscreen products. And then I met Badri, and we were talking about Zoochem's process for making xylitol, which is a sweetener used in confectionery products like gum. And we make that, right now it's being made in China at large scale from corn cobs, and we started talking about, boy, it would be great to make here in the US. We need a good feedstock here, and we started talking about soybean hulls, and it became pretty evident that that could be an excellent feedstock for making xylitol. So we have as Bryant mentioned, that's our current project with the Soybean Association, is to find ways to turn soybean hulls into this xylitol sweetener. And also as a side project, then finding the use for the protein, the soybean protein, to actually feed fermentation, so you can reduce the cost of the media that's needed to do large-scale fermentations, which is the biggest cost of the project. So,
and the last time I ever sat in a chemistry class was almost 30 years ago. So between Google and bothering the hell out of him, I was like, tell me one more time, what happens to the sugar? So thank you for being patient. Dusty?
Feel like I'm back in a chemistry class. So my name is Dusty McKinnon. I'm with Better Fiber Technologies. I started Better Fibers as a founder a couple of years ago. I've been working in the space of agriculture residue to textile grade fibers for fashion companies for the better part of a decade. Worked with a lot of different startups, especially in textiles. I'd have a very interesting role with some fashion brands that would say, we want to go to, let's say, tropical fibers this year. They drop me in a plane in a jungle and say, go find banana trees and figure out how to put them into jumpers for Adidas. So I would call them back and say, well, how many donkeys are you going to buy? Because we got to get these trees off the side of a mountain. So listening today a lot about infrastructure and what actually happens versus early stage startups, I think there's a major gap in that. When you come in as a consultant, the client says, hey, we want a completely circular process to manufacture hemp. So I built that project out for this company. We used weed straw, we used pyrolysis, we took the pyrolytic oils to remove the waxes off the hemp and then flush the biochar to get the alkali chemistry. And basically I told the client, you're gonna build a $300 million plant to sell $500 t-shirts. And the client said, that's not your job to engineer the plant, your job is to figure out the science. So after doing that for several years, I was actually complaining to a client of mine, local in the States here, and saying, look, I just want to make better fibers. You know, I just want to get out there. The market wants more sustainable fibers. We don't have to have the best. Can we start with better? And the client said, why don't you just do it and we'll support you. And so that client happens to control 1 million tons of biomass a year. And now I'm no longer with the brands, I'm with the aggregators and working with the farmers. So that's the brief story of where I come from. And soy is new to me, but we do a lot of work in wheat straw, bamboo, hemp, flax, and very excited about Peoria. It looks like a great place, and excited to learn more about soy and how we can integrate those products into the process.
I really like the idea of the $300 million factory to make $500 t-shirts. We'll come back to that after Jen is done.
Hi, everybody. My name is Jen Fuller. I was introduced to the soybean innovation folks by way of the USDA ARS lab here in Peoria. I discovered the USDA ARS labs through the work that I'm doing, which is kind of a new space for me. So my background is actually in art. I spent the last decade running a glass blowing studio and a makerspace. So this is completely new to me, and I'm not as hip to all the science as you guys are. But my work is developing a baby diaper that's disposable. First criteria we want to hit is that it is a low-cost product. Second criteria is we are trying to avoid any petroleum-based stuff as best we can. And so the first thing we really started with was the superabsorbent polymer. So we think that there's some promise in soy, particularly soy hulls, which I know aren't the probably easiest way to get there, but might help us keep costs down. And so that is why I'm here today.
Well, you know, we can draw from some of Dusty's experience and hire that consultant. And speaking of consultants, here's kind of how it works. So all you have to do is, you know, let's say that you are a mouse and a cat is constantly chasing you around. You hire the consultant and say, what do I do now? And the consultant does a lot of work. They use AI these days, and they say, all you need to do, mouse, is become a dog, and you can chase the cat instead of the cat chasing you. And then the mouse says, but how do I become a dog? And the consultant says, my job is to only give you strategy. Execution is your problem. But the good news is, that is the gap that we hope to plug as the Illinois Soybean Association. There is a big gap between the idea producers and, frankly, the researchers and commercialization. So in the previous panel, you saw folks that have gone a little farther into the production side. The folks here, and David, certainly you have experience in going all the way and your multiple startups. But the whole goal would be to give folks like the Gens of the world and give resources to the Martys of the world, and David, who's already looking at new ones, and Dusty, who's not yet into soy. He is open to being airdropped into a forest with banana trees, so if we drop him in a soybean field, you know, it may work, we never know. But the idea is to give people the missing pieces and create a value chain. So speaking of which, Marty, you know, you talked about how you were working a lot with hemp, and I ordered soy protein for soy milkshakes from Amazon and shipped it to him. And, and so I said, well, tell us what you can do. So that is how good the supply chain was. What did you do when you got that? You had a little bit with your milk, and then what did you do?
Right after having a milkshake, I called for a meeting. This was quite new to, by the way, I have Ian and Ryan, my very talented students here that are standing also by the booth. I called for a meeting that I had this conversation with Battery, and we wanted to give it a try. So I told Battery I'm not going to get into any sort of contract or anything before I try it. So just ship me something, let me try it. And that was the very first time we had soy protein in the lab, and I asked my students, give it a try, start working with it. We were shooting for something between 15 to 30% that would make us happy, and then a few days later I received an email from them that, well, we made something 90%, 90% out of it with quite promising properties. And immediately I forwarded that email to Battery that we are up to something. So we started working on it. It's not the we have had easier material to work with. Like I've been told by my students that there is a temperature that you should be very concerned about, because you cannot go to those temperatures that we usually heat up other polymers or other materials, because that's gonna burn this material. They are not very easy to mold, so we had to figure out specific SOPs to mold it and then get it out of the mold. They worked few hours to get it out of the extrusion molding machine, but eventually we got those materials, and we do have samples out there, but it's still at the beginning of, I can't comment so much on it because we are just about to start this a year contract with Illinois Soybean Association. There's so much on the table. But then there are other products that very early stages of working we look promising. Two of those, if I want to name, is the one that I recently shared with Badri was like this other soy-based material. I had this conversation with Badri that this is clear plastic, this is going to be used for food packaging. We are looking into making an edible version of it, but the problem is we're not sure if it's going to look very clear or if it smells bad. And Badri was like, that's what I love about working with Badri, is like we're going to find an application for it. Like if it's not good for eating or if it's not good for food packaging, it's good for something because outstanding mechanical and chemical properties. Other product which is soy-based polymer that we are working on, and to the best of our knowledge, we are the second team in the world that are investigating these, are biodegradable circuit boards, but these have been around. The difference here is the biodegradable circuit board that we are synthesizing and producing are flame retardant, thermally stable. So you know there are biodegradable circuit boards out there that in order to print on it, people use a technology called cold printing because they cannot heat it up because it's going to shrink and catch fire. But with the product that we are developing, it's just going to work like a proxy-based circuit board. You can print it, you can use it, and when no longer needed, you can just degrade it, like throw it away.
I guess what you're saying is when the iPhone 19 comes, you can eat the iPhone 18 because the circuit board is
right, somehow. Yeah, that's the status of our work with soy protein and soy-based polymers so far.
Well, I always say, most things are a people business. You go to a physician, there are two doctors, they have the same degree. One of them looks you in the eye and takes care of you. The other one is constantly about how soon am I going to get you out of here so I can see the next patient. One of the greatest things about Marty, and he just alluded to it earlier, he didn't wait for the contract to be signed. He didn't wait for the I's to be dotted and the T's to be crossed. He's a pure scientist at heart and does this for the joy of it. So if you're in this room and you're looking for, hey, how do I go further in my research, I would give a full-throated endorsement of him and his team. And there is another gentleman right next to him who did just the same. And not only that, we put him to work trying to pick up a blue paint bucket full of hull, and you do whatever it takes to make the program succeed. So not sure if you picked up what he said. And I'll give the layperson's overview of it. And this is more fascinating for Illinois and the Peoria region in the medium and long term. The origins of your research was that people wanted to do something with waste. And the way you look for waste is you go in the field and see what's left over. And so some of the folks in this room, some folks from USDA, saw that the corn cob was left on the field. And they said, gee, what can we do with the corn cob? And they realized the corn cob had some sugars, it had some cellulose, and so they developed some IP to convert the sugar into energy and convert the cellulose from xylose to xylitol, and out comes the artificial sugar that you use in your chewing gum. Well, once you come up with the IP, and we saw folks earlier today say, I am moving a $30 million factory to be closer to my input. Well, the corn cobs sit on the field. There isn't a truck that goes to the field to pick up the corn cob and bring it to a giant warehouse. So you can't build a business that relies on corn cobs in the US. so the work starts getting done in China. And the gum that you chew, the sugar that you chew, and there was another reference to it from natural fiber welding earlier today, it's the same chemical structure, however, it is made in a lab. So the artificial sugar in your Wrigley chewing gum is made in a lab. And the thought process that we were able to have, and David started moving it further into fruition, and there is a little box of it right there, and we'll maybe take a look at that later. The thought process is, you still have to start from a cheap product, which is available abundantly in the local area. And I really wanted soy protein to be used everywhere. I was going to make soap out of soy protein, see if it worked, but my wife wouldn't let me. But the idea was to see if we could use protein, but he said, no, I like hull, because hull has more cellulose, and I need both the sugar and the cellulose. And so he started experimenting with the hull. Tell us what happened and what you found out.
Yeah, so, well, first of all, xylitol is it's a alternate sweetener, not an artificial sweetener. I say that all the time too. So, but it's a natural sweetener.
My lessons continue.
Yeah, great. So what we found is there's a good amount of the hemicellulose material in there that contains the xylose that we need to convert to xylitol. We've found about 15%, maybe more in some hulls. And so that's a really good starting point for being able to then extract that material from the inexpensive soybean hulls and convert it to the xylitol. So we've been able to extract it, we've been able to purify it to a certain level, and now we're working on optimizing that, and hopefully within the next few weeks we'll be able to actually make some samples of xylitol out of the material, pure xylitol that's as good as the stuff that you can buy that's chemically made or that we're making by fermentation right now in China. So, yeah.
So the reason why I wanted David to elaborate on that is to again appeal to the researchers in the room. We didn't know whether it was going to be successful or not, but we knew that the team behind it had the talent and the knowledge to go in the right direction. And so we don't need a bulletproof plan of this is exactly how it is going to work. And David, yet again, was able to just go run with it, create a small pilot, and say, I think this is feasible. At least I know that the right ingredients are there. And so the appeal to the rest of the folks here, and we'll talk about the challenges and things like that tomorrow, is you don't need to have the perfect idea. You just need to have passion, get the right resources together, some of whom may already be in this room today. Put the pieces together. We'll help you with capital. We'll help you with processes. We'll bring additional resources. So, Charlie Munger, rest in peace, would say the worst thing you could possibly do is to show up as a one-legged man in an ass-kicking contest. And so if you're doing it by yourself, you may want to use your faculties, but you may not have all of it to win in that game. We will put the rest of the pieces together for you. And the rest of the pieces may be capital. In some cases, it might be a scientist. In some cases, it's an ecosystem. That is what we hope to bring. Now, Dusty, you haven't yet worked with soy. Tell us about what you learned working with bamboo and other biofibers and what you anticipate as the biggest challenges as you see ahead.
The challenge really is like a homogeneous feedstock, right? So looking into soy too, I'd be very, very interested in working with stover and running the similar process that I do with wheat straw, because I could see a lot of similarities, silica issues aside from that. But I actually would like to just touch base on the idea of filling in the gaps, and then you just also mentioned doing research, but then really giving people the opportunity to solve problems on their own. So having the faith and the trust in the team. And that's really what I've relied on for the last 2 decades of my career. I was able to build an oil and gas wastewater platform for recovery with institutions and universities. And my first mentor was like captain of the Red Army who did hydrogen bombs. And so he was just a brilliant scientist that used to always tell me, don't let grass grow under your feet. And basically that's been the MO, is just moving it forward, checking in with the team, giving them the space to go and to explore the research, and having strong scientific people around. And so I totally believe in the fact that the resources are here, and have built a career in aligning those resources from technical to brand and to capital. And so that's been my role, is the communication of how to let the researcher or the institution have the rope to go and do what they know way better than I do, and then to communicate that to venture capital and get the funding to support it.
And the takeaway from the work we hope to be able to accomplish with Dusty is, you don't have to be working with soy today. You may be working with petroleum. You may be working with plastics. You may be working with lubricants. If there is an opportunity for soy to play a role in that solution, we will work on it together with you. So it doesn't mean, and we'll go to Jennifer here in a second. So in Jennifer's case, she's as green as I was 5 years ago, possibly better than me, because she learns faster. But the whole idea here is you have one natural resource, a few missing pieces, a team, some of which maybe you're missing portions of the team, and we'll make introductions of other people that we know. So speaking of which, the idea, the reason why we have Dusty here is to show that you could be working with a different feedstock. We can work with you to introduce soy into a process you already have. Jen, tell us about how far along you are, prototypes, anything else.
We are probably about as far along as we can get on our own. So I have a small team who is amazing back at home, and we're mostly engineers. So we don't have the kind of scientific background, but we do feel that something is there. And in my case in particular, we think that we could think about our product a little bit differently than what's out there. You might find on any shelf in the store that there are diapers that claim that they are green, and to some extent, but really they're just doing the same thing. You've still got the super absorbent polymer, you still have the PE film, you still have the PE nonwovens, and then closures and elastics and all that stuff too. So we're really challenging ourselves to kind of think about that, to kind of rebel from that point. I mean, we can't reinvent the wheel entirely. There's not much of a reason to do that. But if we can maybe change the mindset of what expectations are, and I don't know how much people know, but a diaper producer might put more super absorbent polymer in diapers that are sold in the United States versus south of here. So there's regional expectations. In some cultures, if a diaper is not bulky, they don't trust it. So, we're kind of working with a lot of psychological stuff as well, and then it'll end up being a lot of marketing. So as far as we think we're close to at least having our recipe, but we think we can fine tune it. We need some help with that.
Well, you're certainly talking to the right crowd here, and we'll figure out, the parts that we would talk about, and I'll go to Marty again. One of the things the Soy Innovation Center looks for is not a 3-year roadmap and we get a document to put on the shelf at the end of it. We have no interest in that. You need to have very frequent deliverables and milestones so we can have a go, no-go checkpoint. Marty, we talked about project timelines. Tell us more about what you are thinking, what can be accomplished. I mean, making a soy-based spoon seems like research for 10 years. What are the milestones you're looking at?
One point I like to mention here that you might ask, well, soy-based spoons are already out there. You might have seen it, Google it. I have seen it out there, but then there are also hemp-based products out there. The very first time we started working with hemp, we Googled, was no ChatGPT back then, and then we found out, well, there are companies, of course, mostly located in California. They claim to be hemp-based producers, hemp-based product producers, but then when we further investigated, the percentage of hemp in their product was like 5% to 15%, 10%, 12%, mostly as a filler. So it's not like, well, we are reinventing the wheel, as you mentioned. No, we certainly are not, because The one thing that I like is to cross all these preset boundaries. Like the people have been mass producing hemp-based products, 15% only now. We are 60% into it. They have been using it as a filler only now. We are using it as reinforcement. We have looked into how we can improve the mechanical and chemical structure and properties. So when it comes to soy as well, yes, soy, and I know for the fact that there is at least one company out there, but then again, the percentage that they use for soy protein, that's of course is not a reinforcement, that's a filler, but then I don't want to just put 5% into it and the rest comes from other polymers. No, it's a quite large percentage of soy, because this is going to be a good source for those waste products by Soybean Association, right? And within the 7 months, the milestones that we are hoping to achieve, so this is going to start May 15th and then end by December 14th. We are hoping to, first of all, develop a very clear step-by-step recipe for large-scale production of this at every single step, what products goes into it, and then what the production procedure are, which machineries, what setup you put on machineries to get the product out, and in terms of the rates and temperatures and pressures and so on and so forth. Then we get into the testing. There are so many tests that you have to pass, and it's not like only for the US, so we are also trying to pass all the tests required by EU and UK and Canada as well. Then it comes to, and then the final piece and step comes to also degradation. That's very important. You want to test and see in how long this degrades. By the way, we can customize the degradation period. You want a material to degrade within a certain amount of time. Certainly, we can look at it. And then at the very end, I have a very knowledgeable expert colleague in Department of Economics, Dr. Anna Kliss. We are going to look into, well, how much does it cost? In larger scale, not in lab scale. That's the thing, like her expertise would help me understand, well, we are producing 100 pieces in the lab. What if we want to go 100,000 pieces? Then how much would every single piece cost? How we can get the cost further down? And then how much competitive edge we have in the market when we get into the market.
So I guess the key takeaway there is the first deliverable is somewhere in the order of 7 months. And that doesn't mean we don't even talk for those 7 months. And the reason I'm highlighting that is for the folks here who are looking at what is this contest about, how do I participate, what can I do, what can't I do, what we are looking for are projects with clear, achievable goals with mid-term deliverable dates that we can kind of use as a toll gate for go, no go. So if you're going to take 6-9 months to research whether or not that is the right thing to do, you may want to wait a year. Or if you want to talk to us, we can create an interim goal. Well, if you already think X is possible, why don't we start taking the first bite out of the apple? Don't shove the whole thing into your mouth. It's not going to fit. So we will work with you to define what is an achievable goal in a reasonable time period so we can set a milestone, and we'll figure out how to work with you after that. And that is a very important thing. David, you talk about milestones and timelines for you.
Yeah, we do a lot. We do milestones and go no go decisions on pretty much all of our projects. We do a lot of work for other people, developing bioprocess for them and stuff. And it's really important to early on try to design a project so you know whether you should keep going or stop, because you don't want to waste your time or money or the people you're working with, their time or money. So this whole project, this first part, is a go no go decision for whether this can go to pilot. And there's a number of go, no go milestone steps along the way. As Brian talked about a little bit, the first step was to find out, do we have xylose? Can we get xylose out of the soybean hulls? Brian's doing all the work in the lab, so everything I'm talking about, he's actually the one doing it. The second part, as he mentioned, is then can we optimize the conditions to get that xylose out, so that we know we have a clean xylose that we can put into a fermentation. And then the third part is can we do a fermentation and get a good yield of xylitol out of that? And then can we actually purify the xylitol in a cost-effective way? And by the end, we'll probably have an idea of some of the economics as well, too, of what the process might look to at scale.
And the reality is, if we had defined phase one, part one of the project, just as we just want to make sure that there is enough xylose in the hull, that could be project A. And then you go to the next one, and I'm again repeating myself, there is a different phase that we enter into tomorrow, where we say, here are 5 subject areas. We're not looking for you to land a rocket made out of soy in the moon day after tomorrow. So start thinking about what are achievable, simple steps. And the second part that Todd indicated earlier is, we're not a grant organization. We are looking for a return for the farmers. And so if it is IP that you absolutely positively say this is so important for our institution, to the extent that we can build upon the IP and you are willing to participate with us in it, it's a great candidate. If it is IP and you already use feedstock A, which is not soy, and we can co-develop that to use soy as a feedstock, we don't need your IP that existed before you walked in the door. We're only looking to participate in the value we create. So those are simple things for you to keep in mind, and we'll lay out the 5 areas that are very important to us. Todd mentioned them before as well. And if you have another idea that is tangentially related, maybe to some extent unrelated, we'll definitely look at it. But Todd used the 3 magic words: it needs to move the pile. And what does moving the pile mean? Illinois produces $11 billion worth of soy. That's a really big pile. And I constantly still hear ideas about, well, we can increase the yield. Well, that makes the pile bigger. It doesn't move the pile. Well, I can help the farmer grow bees on the side and they can have honey. And I'm like, that gives them more money to watch Netflix, but it doesn't move the pile. So you have to continuously keep thinking about, did I move the pile? If you moved the pile, we want to hear about it. Well, let's go to Dusty. The question I would have for you is, we talked about these 7-month and 12-month, and I realize these are wonderful lab experiments. How long does it take for you to do another round of innovation? How do you do it in a commercial entity?
Sure. So these are great timelines, and I was actually at Peoria next, and I saw your team, and we have some projects to discuss, both of you. It's very interesting. I see that I come from the Canadian landscape too, so I actually live in Whistler, and I've been doing a lot of grants and research projects in Canada for about 20 years. The way it works in Canada, projects are much longer term. You get like a National Research Council grant, it's all reimbursed, whereas I wrote an SBIR, they just write you a check and say, go spend it, and when you run out, come back and get another 1.1 million. So the grant system is much, much better and more lucrative in the US, and having the cash allows you to engage and to pay for services and set milestones and targets and go, no-go stage gates, which is a much better ecosystem here. Whereas in Canada, we spend all the money up front, 2 months goes by, we ask for reimburse, we send that back, and then we might get a check in the mail. Through the mail, like eventually. So it takes a regular research project. Let's say I wanted to do a soy project in Canada. I would engage an institution, and I do a lot of research in Europe too. So Germany takes even longer than Canada. So Germany, they have all these rules and regulations, and then they got to go to their board and get projects approved. So even discussing a project, 2 months, getting a project approved, 4 to 6 months. Engaging in the project, finding a research assistant, student, putting it together, you're another 3-4 months. So your timeline of 8 months to finish a project is my timeline of starting a project in Europe. In Canada, it's probably 6 months. Here, it's much, much quicker.
So what you're saying is the projects we turn away, they could go to Canada.
Please, I will help you find budgets.
So I guess I had another question there.
Sure.
In your existing organization, assume it's not grant money.
Okay.
And you want to look at, hey, how do I retweak this process? How do you set goals, and how long does it take to turn the ship in some ways?
So one thing that's been really interesting, I mean, I can bake you a cake if you give me time, people, and money, right? So I think we all can. So if you have the right ingredients of time, people, and money, things can move much quicker. Working in the startup realm, as I have been for a long time, we have a lot of time, we're limited on people, and we don't have much money. And so you really have to leverage projects. So I have different institutions that are kind of go-to. There's fee-for-service institutions. So in pulping, there's one institution I can go to for a $10,000 or $15,000 budget and a 2-week project. I can get results. And that's if you have the cash, we just go spend it. Other institutions, I do work in Central America. They take much, much longer, but it's super cheap. If I need testing done, I go to CITRA, the Southern Institute of Technology in India, and that's like $1,000 will get you everything you need done fairly quickly. So it just really depends. It's a global economy. We do research all around the world. But for example, like one project that's really got my attention is soy hulls, because I'm actually converting wheat straw into molded fiber and molded packaging. And I spoke with your students over here and know about the upcoming projects that you're doing. It would be really interesting to do a combined project where we have a base of wheat straw, utilizing the technology we've developed, and then seeing if the soy hull goes in, what we'd have to do and what the strength properties are. So there's fast track projects, like I say, that can kind of omnibus with current projects that give you the results you're looking for.
That would precisely be a great example of taking multiple pieces and giving it the oomph to go faster. Yeah. Jennifer, what has been your experience in terms of cycle time? Now you have a smaller team, you're nimbler. So if you wanted to try a new compound, or if you now I understand you don't have the scientists, but I would imagine you have people who just want to try things. Tell us more.
Yeah. Well, I'm very fortunate to have somebody on my team who focuses solely on maximum efficiency. So he does a lot of favors for us in that regard. But we are able to, I mean, it's almost as soon as we can order something and get it in our lab, and then put those pieces together, and then we make a call. It's, will it work or will it not? Or does it require further investigation? We are fortunate to not have to worry too much about time, but we like to work as quickly as possible. I think it really just depends on what it is. And for us, because we are really doing things so much differently than what's out there, and it is kind of brand new, I think we give ourselves a little bit of slack in that, because we are, as far as we know, doing things that nobody's, there's a lot of things people have done before, but have they ever put in a diaper and then tested it and made sure that moms are actually okay with it, which is, a huge part of our project. And so the faster that we can get to the minimum viable product, and the sooner we can get it out in the field, I think we'll be able to accelerate things from there.
It's wonderful. The reason we dig into some of these is you may come up with an idea, and in the process of chasing that idea, and that's what Marty was alluding to earlier, he works every day and he sends pictures of, look at my new baby, I invented this thing. And so he sent a picture of what looked like M&Ms inside a translucent wrapper. And the whole idea of scientific discovery is a beautiful thing. You think you're going towards there, and Christopher Columbus allegedly came here making the wrong left turn. And so as long as you are open to getting influenced with the right resources, it's okay if your first idea is not the right idea. And we would welcome we'll welcome hearing more of your ideas, and we'll talk about what general guidelines we have. What we are looking for are clear and crisp milestones. If you don't have them, we'll work with you to define them. If you don't have some of the people, we'll find the people. What we want is reasonable time frames, and we'll discuss the investment side of the house. And the most important part, Jennifer said earlier, is, will the customer accept it? One of the things we're also going to do is not fund science experiments. What I mean by that is, it's wonderful to know that you can mine gold in your backyard, but then you're going to spend $3 million to find $20 worth of a small nugget. And so we have to make sure that there is real demand. We have to make sure there is a pathway to commercialization. So there is some level of discipline that is going to happen earlier. And if we are able to do that, we'll be a very willing and able partner who brings a lot of resources to the table. Well, I'll kind of go in the reverse direction. We don't want to make it all about chemistry. You want to tell us something we don't know about you, personal life, interesting?
Big food nerd, so I guess kind of a food enthusiast. And it's interesting to me, kind of as I learn more and more about science, how much of that really overlaps from my kitchen at home to my lab at work.
The glaze on the burger, if you eat burgers at all, is made from soy, just so you know.
I did not know that.
And Impossible, I believe it's Impossible, I might have it wrong. I think Impossible meat is made from soy, and Beyond is peanut or one of the others.
Yeah,
pea.
I am actually a vegetarian. So through another visit to a different ARS lab, I got to see them extract, I think, a lot of beans and peas, so that protein has a lot of value because it can go into stuff like that. So what do you do with the starches and all that other stuff?
And to be clear, we're not looking for human uses. We're not looking in that area. We're looking for industrial uses. You will see the 5 areas I think Todd alluded earlier. Go ahead, Dusty.
Something about me. All right, I have a hobby farm up in the mountains in Canada. There's no hobby in farming, but we have a little horse rescue. There's some wild horses that roam around the area, and we bring them in and train them and rehome them and give the money back to the native community.
One of the greatest sources of innovation is to solve problems you already face that ideally is shared by many others. And I say this because many times you ask people, why did you do that? And they would say, I was really solving a problem for me. And a lot of people own horses, and there may be things that you can look at, and I'm illustrating that as a way for you to think. I constantly try and think about what is a problem I face that I can solve, that others can solve too. So if you say, I'm not a chemist, I'm not a scientist, what idea am I going to come up with? I would suggest, and I'm part of a couple of accelerators, and the students would walk in, and I would always say, tell me what frustrated you last week. Tell me what irritated you last week. And you start walking back from there. Soy may or may not be a solution, but the journey of exploring that problem hopefully will lead to good results. David, something about you?
Let's see. Okay. Well, I guess I play guitar, and I sometimes build guitars, not very well, but they're always drying out and cracking, and I'm really excited to try our soybean UV protection formula on it to see if I can preserve the wood. So I guess that's...
So there are soy-based oils, there are gun oils.
So we make the cosmetic product I said is a UV and photoprotectant for cosmetics, and it probably works in a lot of different applications, and it might work really well for that. So
that's awesome.
Yeah, and as I was listening to the first USDA talk on using the different oils for protecting wood and finishes, again, maybe that popped into my head while we were talking.
That's awesome. Marty?
I guess I'm a good cook, but unfortunately I'm not allowed in the kitchen. You can ask my wife further about it, why I'm not. One last thing, if I may add, is I know there have been hesitations about reaching out to universities and working with universities due to sometimes outrageous overhead rates, 50 to 70 to 80%. But doesn't apply to every university, but due to recent changes and developments at the federal government level, now these rates are more negotiable. So don't be afraid to reach out and ask for newer, lower overhead rates at universities.
Well, Marty, I want to end on something more exciting than university funding and overhead. Now, Marty lived in Alberta, Canada, and he tells me the temperatures there were so cold, penguins asked for sweaters. Can you tell us more?
A quick funny story. The very first year, I moved to Illinois back in 2018. The very first semester, like it was about November, December, it was early winter season. It was 2:30 in the afternoon. We were right on the meeting. People were looking out in the window. It was just started snowing, and people were like, oh, we have to get out of this meeting. We have to run back home. We have to commute, and the roads are going to be covered with the snow and everything. And I was like, really? And like 7 months a year, those were covered with snow, and not even a single daycare was closed 1 day or 1 hour. But then I got used to it, and probably because things are different there. But that was, to me, very new to understand. The definition of winter is very different here compared to where I used to live up in Canada.
Well, I think that's a good way to think about, if you complain about cold, you could be in Alberta. Well, thank you to all of you for your time. Any other questions for the folks here? Maybe we'll turn over for a couple of questions and stop after that. And there are no questions. Okay, thank you.
Everyone, this is we're going to adjourn for the day. For those of you that are attending the dinner tonight, that will start at 6 o'clock. And then there will be breakfast here tomorrow starting at 8. And we will finish up talking at that point. So thank you, everybody, for your attendance.